Hello everyone, welcome back to Mathematics. So for today's video, we'll be focusing on this year's trial paper for Kedah paper 2. And sorry about the delay, a few things going on here and there, but the video is finally out. Alright, so the difficulty of this paper, I would say it's similar to paper 1. So of course in this paper, there are some easy questions and there are some difficult questions. Alright, but what I do notice in this paper is the section C questions. So as you know, section C is the famous section where students will aim the easier chapters to score well, right? But for this year, of course, Kedah have its own tricks up their sleeves. So for this year, they made all the section C questions to be harder than usual, right? So a lot of students might unable to score well than before, so I feel it's a bit unfair lah. But it's okay. So later in the video, I will be sharing all the techniques and all the tips to score those kind of complex questions lah. So later, if SPM have the same result also, then we can use the techniques and the tips here to score it well. Alright? And also for this year, I added this label. So later when you see in the question discussion, if you see this label unique here, right? This label means that that question appeared more often in the trial papers compared to the questions that we do in textbook or the exercise books. Alright, so without further ado, let's go through paper 2 together. Question 1, coming from system of equations, and here we have a simultaneous equation and it gave us the solution already, which is 3m and negative 2k, but as you can see inside, there are unknowns. And this question tells us to find the value of those unknowns. Alright, so to solve this question, why not we solve the simultaneous equation first, meaning finding the value of x and y. Alright, so that will be our solution, and then we are going to compare our solution with their solution to find the value of m and k. Right? So how do we solve simultaneous equations? Well, we can look at the methods that we have learned in this chapter, right? So there are two. One is called the elimination method and the other one is called the substitution method. So how do we choose those methods is through the type of the equations. Alright? So for elimination is linear equations. Substitution is for non-linear equations. So what do we mean by linear and non-linear? So if you recall back, linear is actually those unknowns like x, y, z. They don't have power and they don't multiply within each other. But for non-linear, it would be something like x squared, y squared, or the two unknowns can be multiplied together. So if you go back to the question, you can see that those unknowns are actually multiplied. Okay, so this means these equations are non-linear and we need to use the substitution method to solve. So first thing first, I think we need to decide whether which equation should be substituted into the other equation. Would it be this one substitute inside here, or this one substitute inside here? Right, so what I always recommend students is to choose the more simplified equation to substitute into the more complex equation. So if you compare these two, very obvious that this is much more complex, right? Because look at the unknowns that it has. Y and then x and then y and then there's another x, x, y here. So there are total 6 unknowns, which very complex. So what we're going to do is we are going to choose this one, which is more simplified, and substitute into here. Okay, so before we substitute, let us make one side have one unknown only. So the fastest way to do that is for the 2, let me move it to the other side. So on the right side, there's just one unknown, which is y. Okay, which is what we want. So it will look like this. Okay, one unknown on the left, the rest of the things to the right side. So now we can use this one to substitute inside here. But before we substitute, if you look at the equation here, there are 3 y's. So if we substitute this fraction into these 3 places, you can imagine that the steps they are doing later would be very, very complex. A lot of things need to change here and there. So let us take a step back and let's simplify this equation first. Maybe there are some things that we can cross off later on, and then it will make our life more easier, right? So let us multiply the unknowns into the bracket first. Alright, so it will be something like this. And now if you compare left and right side, there is xy for both sides. And both of them are positive. So if we move one of them to the other side, technically it's xy minus xy, meaning 0. Meaning we can cross off these two things. So now you can see the equation is much more simplified. From 3 y's, now it's just 1 y. Which make our life more easier because we just need to substitute one fraction into one place only instead of 3 places just now. Right? So sometimes we need to take a step back. Let's simplify the equation first, then only substitute. Alright? So now we are just going to substitute this fraction into 1y here. Right? And it would be something like this. And then for the square, we are going to apply top and the bottom. Okay, so it will be something like this. So 2 square would be 4. And here we are going to expand it and then cross multiply. So this means that 3x minus 5, I'm going to write twice. And then the things inside, we are going to cross multiply. So 3x multiply 3x, 3x multiply negative 5, negative 5 multiply 3x, negative 5 multiply negative 5. So the result would be something like this. And for the 4 here, we are going to move it to the other side. So meaning multiply 4 with these two numbers here. Okay, then I'm going to move all of these numbers to the left side. So simplify, it will be something like this. And then if you look at the 3 numbers here, all of them actually can be divided by 5. Okay, so we are going to further simplify, divide 5, and we'll get this equation. So this is actually a quadratic equation, so we can factorize using our calculator to find the 2 values of x. But when you put inside, you will notice that there will be only one answer. So meaning the 2 values of x, both of them have the same answer, right? Which is 3. Okay, so now we found our x value. So why not we substitute this value into here to find the value of y. Okay, so y would be 2. So now we have found out our solution already. So now we can compare it into the question solution to find m and k. Alright, so for x, we are going to compare 3m and 3. And for y, oops, sorry. Let me erase this. Okay, so for y, it would be negative 2k compare with 2. And then once we compare, we move the numbers here and there, and we can find the value of m and k already. So m would be 1, k would be negative 1. For the next question, I'm not going to review is from which chapter first until we go to part A1. Alright, so in this question, we have the graph and the equation of function f, and in part A1 we need to find out the area of B, which is here, okay, this region. So to find the area which is bounded by the curve, meaning controlled by the curve, or under the curve, we need to use the integration method. Alright, so this question comes from the integration chapter, and if we recall back, to find the area under the curve, we have 2 ways. Right? So the first way is using the x-axis, the other way is using the y-axis. But which way we need to choose from? This we need to look at the shape of the area. Right? So we need to look at, for this area, is it bounded by the x-axis or the y-axis? Or meaning controlled by the x-axis or the y-axis? So if you look at here, you can see that this line bounds or controls the shape, right? And this line is actually part of the x-axis, right? So this means this area is bounded by the x-axis. Hence, we need to use the x-axis way to find out the area. Alright, so we're going to start off with putting the integral at the front and dx at the back. X is because we are using the x-axis way. And for the two values here, so a is the lower limit, b is the upper limit. So since we are using the x-axis, we are going to find the lowest x value and the highest x value according to the area here. Okay, so the lowest x value would be here, right, which is 0. Then the highest x value would be the line that is drawn here, which is 3. Okay, and for the y here, it would be the equation of the curve, which is given here. Alright, this one, negative x cubed plus 3x squared plus 9x. Okay, so once we have all the information ready, then we are ready to integrate. But before we integrate, let me separate this equation by the plus here, so you can clearly see that we need to integrate 3 things. 1, 2, 3. Alright, so let's go to the first one. If we want to integrate, what we need to do is to add 1 to the power, and then we are going to divide it with the new power, 3 plus 1, which is 4. Okay, so here will be negative x to the power of 4 divided by 4. Right, same goes to the second thing here. So power, we add 1 and we divide with the new power, 2 plus 1, 3. Okay, and this one as well. So the power here, originally it was 1, so I add 1 to the power. So I'm going to divide with the new power, which is 1 plus 1, 2. Okay, and then don't forget to put the limits at the end of the bracket here. Okay, so once we have done this, then we are going to substitute the two values inside the bracket here, and then we are going to find its difference. Alright, so for the first one, we just need to substitute x with 3, so all the x here will become 3. Okay, the rest of the things will remain the same, and for the 0 as well. Okay, so as you can see, all the x has become 0, and these two values, we are going to find the difference. That's why here there's a minus here. Okay, so you can put all of this into your calculator, and then you can get your answer, 47 and 1 over 4 units squared. For the next part, it says, hence, find the area bounded by x equals to k to x equals to 3 in terms of k. So k is here, so means if from k to 3, we need to find the area for a and b as well. Alright, so for the area bounded, it would be these two areas add up together. Alright, add up to find the total. But before we find area A, let us recall back a very important point when we are trying to find areas using integration. Okay, so if you focus on this one, if the regions that we are trying to find is above the x-axis, okay, above the x-axis, the value would be positive. If the regions we are trying to find is below the x-axis, the value would be negative. Alright, so for example, in part A1, right, this region is above the x-axis. That's why the value here is positive. But if we try to find area A, right, later on, it would be a negative value because it is below the x-axis. Okay, below the x-axis. So you can imagine, right, this area A, it will be negative. This area B, it will be a positive value. And if we add them up together, it is like finding the difference between these two areas because one is negative and one is positive. Alright, so we are not finding the difference between the two areas, we are finding the total area. So both of them needs to be positive, right? So one of the ways that we can change area A to become from negative to positive, it is applying the modulus, right? So negative values, if we put into the modulus, then it will be a positive value. So positive and positive, then we can add up to find the total area. Alright, so recap, for regions which are above the x-axis, it will be a positive value. regions which are below the x-axis, it would have a negative value. So because it is negative, we need to change it to positive through applying modulus. Okay, so please note, especially for areas, if you see areas which are below the x-axis, then you need to apply modulus. Alright, so to find area A, we can use back the same technique in part A1, which is using the x-axis way. Alright, so let us put the modulus here first, and then let's put the integral at the front, dx at the back. And to find the limits, so A is the lowest x value, B will be the highest x value in region A. So if you want to find the lowest x value would be on the most left, which is K, and the highest x value would be at the most right, which is here, which is x equals to 0. And for the y, it will be the curve equation. So since we are using the same curve, then we can use back the same equation. Alright, and then at the back, we are going to put the value of area B, which is the answer in part A1. Okay, so this part, actually, we don't need to do the same process in part A1, which is to integrate one by one, and then we substitute the values inside here, and then show all the working. Actually, we don't need it, because it says hence. Hence meaning we can use back the workings here, and then just to write out the final result. Okay, so we just need to write out the final result. Okay, so to show the workings, I will be changing some things here in part A1, but please do not do this during your exam, It's just for demonstration purposes. Okay, so for all the trees here, let me change to 0. Okay, 0, 0, and here 0 as well. Then for the zeros here, all will be changing to K. Okay, why I changed these two is because this is the limits that we have now. Alright, so all the zeros here will become K. Alright, so if we look at here, the first bracket here, so all the values have become 0, and if you imagine, if we try to calculate these three values, right? Actually, if you multiply a value and you divide a value and then you have a power, it will still be 0, right? And then if you minus 0, plus 0, and plus 0, it will still be 0, right? So we are just gonna put 0 here. So for the next part, because we are substituting the value of K, which we don't know what is the value, so we are just going to write out the exact same thing that we have here. Alright, so it's negative K power of 4 over 4, which is here, plus 3K power of 3 divided by 3, and plus 9K squared over 2. Alright, and again at the back, we are going to remain the same value. And now for the negative, we are going to put into the bracket here. So negative values will become positive, which is this one. And for these two positive values, it will become negative. And this would be our final answer. Alright, so you may be asking, hey, teacher, this is actually a negative value. So this modulus should apply to these values and become positive, right? Then that will be our final answer. Okay, it's wrong actually. Okay, because when we are applying modulus, right, we need to have a final value. So final as in, I have known the value of K, right? So let's say it's 1. Okay, let's say it's 1. And then when we have 1, what we do? We try to minus or plus the values that we have inside to find out a final answer. Okay, let's say the final answer is negative 10. Then we only apply the modulus to this negative 10, then find out the answer, right? So for this case, we are not going to apply the modulus first because first thing, we don't know the value of K. And we don't know the final value once we substitute K, right? We don't have that final value. So we are just going to remain the modulus. We don't do anything inside this, the values inside here. Okay, because again, we don't know the value of K, and we don't know the value of K, then we don't know the final answer. If we don't know the final answer, then we cannot apply the modulus. Alright? And another thing to let you know is the y-axis part here. Okay, so there will be cases where the area will be positive or negative. So for y-axis, it would be if the area is on the right side, then it will be positive. If the area is on the left side, then it will be negative. Alright? For part B, we have another new curve. So given the graph and the equation also, we need to find the generated volume. Alright? Volume in terms of pi, if the shaded region is revolved around 270 degrees, okay, 270 degrees around the y-axis. Alright, so to find volume, if we recall back, for integration, we also have two ways, which is using the x-axis or the y-axis way. But this one will be much more straightforward compared to area because the question will tell you to use which axis. Okay, so since it tells us to use the y-axis, then we'll use the y-axis way to find our volume generated. Right, so let's start off with writing out the pi and then followed by the integral. So at the back, we are going to put dy. So why we put y is because we are using the y-axis. Okay, and then for the limits here, because we are using the y-axis, so we need to find the lowest y value and the highest y value according to the shaded region here. Alright, so if you see the lowest y value, it is not given here, but it should be here. Okay, so this is actually the y-intercept of this curve, and as we know, y-intercepts, the x is 0, right? So we're gonna just substitute 0 inside this equation, and then we can find that y is equal to 2. Okay, so the lowest y value here would be 2. And the highest y value would be this line, which is y equals to 4. And inside the integral, we are going to put x squared. Alright, so for this x squared, because we are using dy, the things inside the integral needs to be y also. Okay, so we need to find a way to change this x squared into y. So the things that we can do would be using this equation and we rearrange it. Okay, so we rearrange in the way that x squared is on the left side. Okay, so we change here and there, and then we can find the x squared equals to 2y minus 4. So we are just going to substitute it here. Okay, but before we go to the integration part, we missed out this information. 270 degrees around the y-axis. And in question, they always tell us to turn 360 degrees, or meaning one round, or meaning one cycle around the axis, right? So 270 is not. So what we are going to do is we need to calculate how much of a cycle is 270. So to do that, very simple, we are just going to use 270 degrees divide with the entire cycle or the entire round. Alright, so once we do that, we will calculate that it is 3 over 4. So for this 3 over 4, we are going to put here in front of the integral here. So once we found the answer for the integral, then we can just multiply 3 over 4 to find our final answer. Alright, so now coming back to the things inside this integral, we are now going to integrate it. Okay, so let us separate the values according to the plus and the minus. So here there will be two parts. Alright, so for the first part, same thing as part A, we are going to add 1 to the power and divide with the new power. So originally the power is 1, so plus 1 to the power it will be 2, and we are going to divide with the new power, which is 2. Okay, so it will be something like this. And for the 4 here, since there is no y, then to integrate it, we just add a y to it. So here will be negative 4y. And don't forget to put the limits at the end of the bracket. Okay, so now we are going to substitute the two values here into the bracket and find the difference. Okay, so this will be the result when we substitute 4. So as you can see, all the y's have become 4. And we're going to minus with the value that we substitute 2 inside this bracket, Okay, as you can see, the y has changed to 2. So once we put these two things into calculator, then you can see that for the first bracket is 0, the second bracket is -4, so 0 minus 4, it will be 4, and 4 multiplied with this fraction at the outside of the bracket, it will get 3 pi units cubed. Alright, and for the answer, please do not write this into 3.142 because in the question it tells us to write in terms of pi. In terms of pi meaning we don't touch the pi, we make it as it is. Next question coming from the Indices, Surds and the Logarithms chapter. So for the first part, we are given this equation and you can see there are indices inside. Alright, so this is a indices question and it tells us to express x in terms of y. Alright, so for this kind of indices questions, I'll always follow this rule, which is all the values must have the same base. Okay, so what do we mean by base? So let's say we have this value, let's say a to the power of n. So what I'm referring to the base is the a value here. Okay, so the a value here is base. So here, as you can see, there are a lot of values. For example, 2, 32, and 16. So the rule here is to change all the values to have the same base. And you may be asking, which value should I change to? Well, the rule would be to change it to the smallest value here, the smallest base value here, which is 2. Alright, so for the 32 and the 16, why not we change it to 2 and we need to figure out what is the power for these two numbers. Alright, so if you do a lot of exercise, you will automatically know 2 to the power of something is 16 or 2 to the power of something is 32. But if you don't know, it's okay because you have your own calculator and you can try out the values one by one. Okay, you try out the powers one by one. It's okay. Alright, so you can try out 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is, okay, so this one if you don't know, if you type your calculator, you will get 16. Okay, so this means that this 16, we need to change it to 2 to the power of 4. Alright, and then let's go to the next one. 2 to the power of 5 is 32. Okay, so since we have the 32 here, then we can change it to 2 to the power of 5. Okay, so now you can see all the values have the same base, which is 2. Alright, so now we can combine all these indices already. So recall back the rules when we want to combine these indices. Okay, so if it's multiplied, this means that the power can be added together. If the indices are divided, which means the power can be subtracted or minus. Alright, so here, let's go one by one. So here, it's 2 power of 3x times 2 power of, okay, this should be 1 here. Alright, so we can just add up the powers. So it will be 3x plus 1. Alright, and then we divide. Okay, divide meaning we need to put minus here. Alright, so it will be a minus here. And this 5 will multiply with x minus 1. So it will be something like this. And for the right hand side, it's just 4 times y. Straightforward. Okay, so now you can see both sides have the same base. It's just the power is different. So what we can do is we can just ignore the base here. And then we just focus on the powers. Alright, so on the left hand side, the power, let me simplify it. So once you simplify, you multiply and plus minus there, you will get this result. Negative 2x plus 6. Alright, and on the right side, nothing changes. It's 4y. And now, as you can see, the equation is very simplified already. Then we can go back to the question here and do this thing, which is express x in terms of y. Meaning x on the left, everything else to the right side. So for this equation, what I will do is for the 6, I'll move it to the right side, and also this negative 2, I'm going to move it to the other side, which means dividing it. Okay, so it will be something like this, and then this negative 2 divide with these two values above, and you will get this result. X equals to negative 2y plus 3. For the next part, you can see that this equation, there's a square root here. So this is actually a surd equation. Alright, so we need to use the things that I learned in Surds to find out the value of x. Alright, so this one, let us simplify the equation first. Let's multiply the negative 3 inside the bracket. Okay, so it will be something like this. And now seems like still cannot simplify, so why not we move everything to the left side and see what we can recognize from there. Alright, okay, so for this one, I want you all to focus on the powers between these two x values. Alright, the powers between these two x values. So for the first x, as we know, the power is 1, right? The power is 1. For the second x, because this is a square root, so the power should be 1 over 2, right? Okay, 1 over 2. So if I want to get from 1 over 2 to 1, we multiply 2, right? This thing, this relationship, is something similar to what we've learned in Form 4 Chapter 2, the quadratic equations, right? Because as we know, for quadratic equations, it's like, okay, for example, x squared plus 2x plus 1 equals to 0. This is one of the examples of quadratic equation. And if we focus on the powers of these two x values, alright, for the first one is 2, for the second one it's 1. And if I want to get from 1 to 2, we multiply 2 also, right? Same relationship. So what does this mean for this equation here? Okay, this equation is actually sort of a quadratic equation. It's just that the power is smaller, right? 1 here, here's 1 over 2. This is 2, but here it's 1. So how do we change the equation that we have to become something like this? Alright, so let's start off with the square root x. Square root x, let's change it to another unknown. Let's say it's y. But you'll be asking, why is it the unknown y? Alright, so actually you can use any unknown. Alright, it's just that you cannot use back x. Okay, imagine here, for example, square root x, right? We change it to x, it's like we are just removing the square root. Which doesn't make sense, because if you just remove the square root, something needs to change here also. The other parts of the equation. That's why we don't change it to the same unknown, we use another unknown. Alright, and the second thing is, this unknown, right, as you can see, the power is 1. I don't use y squared, y cubed, because I want to change this square root x part into this value. Alright, and this value's power is 1. That's why here, for the y, I just use power of 1. Alright, so two things. First thing is, don't use back the same unknown. Second thing is, use the power of 1. Because I want to change it to the quadratic equation here. Okay, so square root x here will become y. But how about the x at the front here? Okay, this one, we can just use back this equation. It's just that this square root, we move it to the other side. Okay, so if we move it to the other side, meaning the square will be here. Alright, so x equals to y squared. So this x will be changed to y squared. So now you can see this is actually a quadratic equation. And how do we do it? We just use this, y equals to square root x. So now we have a quadratic equation here, so we can use the normal way to solve it, which is factorization by using calculator, right? And find the two values of y. So once you type in calculator, you will find that y would have two answers. One is 2 and the other one is -5. Right? But take note, yeah, we are finding the value of x, so the y here we need to change back to x. Alright, so we'll use back the same thing here, y equals to square root x. Alright, so we have two answers for square root x, but if you go back to the question here, it says value. Okay, sorry, let me erase this a bit. Okay, it says value, so meaning only one answer for x. So we need to reject either one of it, but which one? Alright, so let's recall back, yeah. Value of x we can only insert 0 and positive values. If we put negative, it will produce an error. And also what we notice is for 0 and positive values, it will only come out 0 and positive values as well. Alright, so for value x, 0 and positive, answers will be also 0 and positive. So this one makes sense, right? Because the value of 2 here is positive, but the other one doesn't make sense because it is a negative value. If x cannot be negative already, how it will come out a negative answer? Alright, so that's why for this negative 5, we need to reject. And for part C, here we have a logarithm equation. So this means that this is a logarithm question and we can use the 3-step method to solve any kind of logarithm question. Alright, so the first step is to change the base. So if we look at the bases of these two logs, you can see that they are different. Alright, so we need to change it to be similar, but which value should we change to? Is it 8 change to 2 or 2 change to 8? So I will always recommend students which is to change to the base which have the smallest value. Alright, the smallest value, which means 8, we change it to 2. Alright, so let's use this formula to change the base. So how do we change the base? Very simple. For the value here, we are going to put it on top. For the old base, which is 8, we are going to put it at the bottom. And for the new base here, we are just going to put the value that we want to change, which is 2. Alright, and for the right side, nothing changes. So here, if you compare left and right side, actually you will notice that both sides have log base 2, 5. Right? So this means we can actually cross off these two logs. And then since on the right side there is just 1 only, right? Because you cross off it, there will be 1. It's not 0, yeah, it's 1. So if we move this to the right side, meaning the denominator move to the right side, then right side will be log base 2, 8. Okay, so now we have k, only k on the left side. It's just that now we need to change this log into a value. Alright, meaning we need to remove the log here. So how do we remove the log here? Well, we need to recall back something we have learned in this chapter also, which is this one. Okay, so if you recall back, if the base and the value is the same, we can change it to 1. Meaning log will disappear. Right? So let's change this 8 to become similar to the base here. Right? So meaning this 8, we need to change it to something like 2 to the power of something. So the value and the base would be the same. And to change 8 into this form, we have actually saw it in part A just now, right? We know that 2 to the power of 3 is 8. Okay, so for this 8, we can just change to 2 to the power of 3. But how do we remove this 3 from the log here? Well, we need to go to step 2 of solving any log questions by using these equations, using these formulas to simplify the thing on the right side. So if you look at the law that involves power, alright, this one, the n here, it says that this n can be moved to the outside of the log and just placed on the left side of the log. Alright, so this 3, same thing as well. We are going to move it to outside of the log and gonna put it on the left side. Alright, so it would be something like this, and for this thing, it will change to 1 because of this rule. So 3 times 1 equals to 3, and we have found the answer. But how about the third step? To change the form. Alright, so actually if you go to the third line, right, you can see that the value of k is already the only thing on the left side. So there is no reason to, I would say, change the push the base here and there. Because on the left side, there is just k only, which is the thing that we are trying to find, right? Yeah, so for the third step, we can just skip, no need to use. Question 4, coming from progressions. So in part A, it says that there is this ball being bounced and reach a height of 120 cm, right? So this means that, okay, let's say I have this ball here, and then I want to bounce it, okay? And then from the first bounce, it reaches a height of 120 cm, okay? The maximum height from the first bounce. Alright, and then it says that this ball will bounce until it stops, so of course, and it says that the maximum height of the ball bounces the fourth time, right? The fourth time is this height, right? So according to this graph here, so since this is the first bounce, then this will be the second bounce, the third bounce, the fourth bounce, alright? So the height that is referring here is this one, okay? So this one will be 320/9. Okay, and also it further says that the maximum height of the ball forms a geometric progression. So means that all of the heights here, including the 120 cm, all of these heights follow geometric progression, or short form GP. Alright, so we to recall back all the formulas in geometric progression, which is in the formula sheet, formula 11 until 13. Okay, and here we need to find out the total maximum heights until the ball stops. So from Tn, Sn, and S-infinity, which one should we use? Right, so that's the question that we always need to ask ourselves. From all of these things here, which one should we choose? So here it says total, so means Tn is out of the question already lah, because we want to find the sum, right? Which is Sn or S-infinity. But how about Sn and S-infinity? Which one should we use? Alright, so I think the main question is, do we know the value of n or not? Right, so the value of n here would be the number of bounces until the ball stops. Okay, do we know how many times the ball bounces until it stops? Right, so let us extend this graph. Alright, so it continue to bounce, right? Continue to bounce. Alright, so at the end of the experiment, right, which the ball is about to stop, you can see that here it's quite impossible to find how many bounce until it really stops, right? Even in real life, when the ball is about to stop, right, the number of bounces there is a lot, right? Because the height where you want to bounce, it becomes smaller and smaller and smaller. So here, in this case, the value of n here is very hard to estimate, very hard to count. That's why to cater this kind of issues, Sn cannot be used, but we can use another way, which is S-infinity. Okay, which is why in this question, we are going to use S-infinity. So this S-infinity, just to share to you all, there are also some keywords one. For example, this one, until something stops. So if you see something like until something stops, then you can use S-infinity, because for this kind of experiments, we really don't know what is the value of n. Alright, so if we don't know the value of n, then we can use S-infinity for our answer. Alright, another example that I can think of is the pendulum, right? This one. It sways to here and to the right side, and then sway back to the left. So the swaying part, same thing as well. When it's about to stop, you don't really know how much swings does it have. Okay, it can be a lot of swings. So again, this kind of experiment, we don't know the value of n, so we also use S-infinity, right, to find the total. Okay, so coming back here, so to find S-infinity, we need to find out two things. One is the A and one is the R. So A here would be the first term, and in this experiment, it would be the maximum height from the first bounce, which we have already found here, which is 120 cm. Okay, but how about the R? Alright, R, it doesn't give us, but it gives us another information, which is, oops, sorry. Let me erase this again, so sorry. Alright, so we have found out that the fourth time achieves this height. So this is actually T4. Okay, so why not we use the Tn formula to find out the value of r? Because in the formula here, we have the value of a already, and we have the n as well. So we can substitute everything that we have into this formula and find out the value of r. Okay, so AR and the n is 4, so 4 minus 1, and right side will be 320 over 9. So I substitute the a inside here, and the power here will become 3. So this 120, I move it to the right side, so means dividing it. And for the cube here, once I move it to the other side, it would be cube root. Alright, cube root. So cube root of 8 over 27, you will get 2 over 3. Okay, so once we have the value of a and the value of r, then we can substitute into this formula to find the S infinity, which is 360 cm. Okay, so sometimes for some questions, they may use other units, so take note, yeah. So for this one, it's cm, so we don't have to change anything lah. So it's 360 cm. And for part B, we have an arithmetic progression here, so we're going to use the formulas from arithmetic progression, which is formula 9 and formula 10 from the formula sheet. Alright, and it says that the sum of the first 4 terms is 46, and it says that the 7th term exceeds twice of the second term, right? It's not terms, it's term, by 5. So now it says we need to find the sum of the 10 even terms. Alright, I think there's a lot of information given here, but I think the first thing that we need to know is how does the progression look like? Meaning, we need to find out the value of a and d from this progression first, before we find the sum of the 10 even terms, right? So we need to figure out the value of a and d. So how do we do that? We can form some equations according to the information given here. Alright, so the first information given here is sum of the first 4 terms, right? Sum is S, first 4 terms. So the n here would be 4. Alright, and is 46, so meaning equals to 46. So this will be our first equation. Alright, then the second equation here, the 7th term, right? So this is not sum, so this is the term itself. So this is T7, and it says that it exceeds twice of the second term. Alright, second term, and it says twice, so I'm gonna multiply 2 here. And it says by 5. So 7th term exceeds this term by 5. So if I want to write these two things into an equation, okay, so let me put those two into an equation first. And then let's see this 5, should I put on the left side or the right side? Okay, so it says 7th term exceeds, right? So means T7 is bigger. So if I want to balance the equation, where should I add the 5? Right side, right? Because right side, previously it was smaller. So I add a 5 here, then I can balance out this equation. So now we have these two equations already, and let's use the formulas here to find out the value of a and d. Okay, so for S4, so S4 would be, n would be 4, and here we'll divide by 2, and a we don't know, so it will remain as 2a, and the n here I'm going to substitute it with 4, so 4 minus 1d, and will equal to 46. So here 4 over 2 here will become 2, and if I simplify the things inside the bracket, it is 2a plus 3d, and then now I move 2 to the other side, so it would be 2a plus 3d equals to 23. Okay, so I think this first equation is simplified already, so let's go to the second one and let's simplify it as well. So T7, so I'm going to use this formula, so a plus n minus 1, so it's 7 minus 1d, and from the right side it would be a plus 2 minus 1d, and plus 5. So I'm going to simplify both sides, and you'll get something like this. And then for the things on the right side, I'm going to move everything to the left. Okay, and now to simplify this one, let me remain a on the left side and the other things to the right side. Okay, so means these two move to the right side. Okay, and then I move the negative to the other side. So means things on the right side, negative to become positive, positive become negative. Okay, so why I say I remain A on the left side only is because I can straight substitute this equation into this equation. So means this A, I can change it to 4D minus 5. So everything in the equation becomes D only. Okay, so if I simplify this equation, then I can find the value of D already. So these are the steps, and you will find out that D is equals to 3. Alright, and this 3 substitute inside here, I will get the value of A, which is 7. Alright, so now we have an idea how does this progression look like. So if we list out the first 4 terms, so T1 is the first term, which is A, which is 7. And if I want to find the second number, is 7 plus the 3 here, because D is 3. Alright, so plus 3, so here will be 10. And if I want to get the next number, also add 3, and so on. Right, so now going back to the question, we need to find the sum of the first even terms. Right, sum is S, and the n here is 10 because the 10 even terms. But what is even terms? Right, even terms is actually, if the value of the term here is even, then it's called even terms, which is T2, T4, and another example is T6, and so on. So now they're telling us to find the sum of these terms. So how do we do it? Well, basically, let us just ignore the odd terms first. Okay, and let's just focus on these numbers. So imagine that we have a new progression, new sequence, and only have these terms. So how do we find the first 10 terms? Okay, very simple. Because this T2 is our first term already, so the new A would be 10. Right? And then let's find out the new D as well. So D here, very simple, is just 16 minus 10. So it would be 6. Right? So now we have the A and D for our new progression. Right? The new progression from the even terms. Okay, so now if we want to find out the S10, we can just use back the formula with our new values of A and D. Alright, so S10 equals to 10 over 2 and 2A. A will be 10, right? Not 7 here, it's 10. And n minus 1, so it's 10 minus 1. And D would be 6. Alright, it's 6 here, not 3. We need to use the new values of A and D. Okay, so once we put this in the calculator, then we can get our final answer, 370. Next question, going into trigonometric functions. So in part A, we need to prove this equation. So I know a lot of students don't like to prove, but let us try our best to solve this kind of questions, right? So I think the first step to prove any kind of equation is, should we start from the left hand side or the right hand side? Okay, so to decide which side to choose, we always choose the more complex side. Okay, because there are much more things to manipulate here and there, and then we can prove the simplified side. Okay, so compared to these two sides, of course, left hand side is much more complex, so we're gonna start off with left hand side. Alright, and if you notice the functions on the left hand side, there are 2a. Okay, 2a. So let's pull all the formulas in the formula sheet that has 2a, okay, which are formula 32 until 34. Okay, so let's match here and there and to see which formula should we use to change the things here. Okay, let's start off with the numerator, cos 2a. So cos 2a is a bit headache because cos 2a there are 3 kinds of formulas. So which one should we use? So I will always recommend students, and I will say this is like a technique. We should always look at the value 1, not the function here, the value 1, right? if you see this value 1 is positive, then you match it with the formula where the value 1 is positive. Okay, so let's look at the first one. This one does not have 1, so very obvious, we will just ignore it. Alright, the second one, you see that the 1 here is negative, but we want positive, so it's not this one as well. Then we are going to use the third equation, the third formula, because the 1 here is positive. So means we can use this formula. Okay, but why I tell you all to look at the value 1 is because if we switch the functions right, okay, so meaning the 2 sine square a, I'm going to move it to the left side. And the cos 2a, of course, will move to the other side. So positive become negative. You can see that it is exactly the same thing here. Right? So this one actually is like an indicator to know which formula to choose. Okay, and once we know that, then we can just straight substitute the things that in the formula. Alright, so this 1 minus cos 2a will directly change to 2 sine square a. Okay, and then for the denominator here is sine 2a. So sine 2a quite straightforward because it's just one formula only. So we're going to use the entire thing here. Alright, so now we can simplify top and the bottom. So we can cross off the 2 here because top and bottom have. And also for the sine 2a, the sine a here as well. Numerator, we have 2 sine a's. Below, we have 1 sine a. So let's cross off one of the sine a's. And once we simplify, then we can get sine a over cos a. But how to get sine a over cos a to become tan a? Well, this is one of the things that we have learned before and it's very, very, very important. Alright, tan a equals to sine a over cos a. So that's why this thing can become tan a. And we have proved the equation. For the next part, we are going to sketch the graph. But what kind of graph? So here we have 2 trigo equations, which means we are going to draw out 2 trigo graphs. Alright, but here it says that we need to draw it on the same Cartesian plane, which means that these 2 graphs, we are going to combine them into one graph. And then we need to find out the number of solutions, which means that the number of intersection points between these 2 graphs. Right? So for these 2 graphs, we are going to combine them. And then from the graph, we see that, oh, how many number of intersection points does it have? So that will be our number of solutions. Alright? And for the graph, it says that we need to draw from 0 until pi only. So pi here is in radians. So if you want to change it into degrees, it's 180 degrees. Which is a little bit different from what we draw all the time, which is from 0 until 360 degrees, right? Because 360 degrees is one cycle. Okay, so since it is just 180 degrees only, so we are just going to draw half of the graph. Okay, but to teach you how to draw out the trigo graphs, let us assume that the question tells us to draw for 360 degrees first. Okay, so once we have the graph, then we change it to 180 degrees. Okay, the change will be quite simple, right? So no need to worry. Alright, so let's start off with the first trigo equation. So if you see the things inside the modulus, it's very familiar, right? Because it is the thing that we have proven in part A just now. So this is actually tan A. So we need to rewrite our equation a bit. So we need to draw out y equals to modulus tan A graph. Alright, but how do we draw out a trigo graph? So let's recall back the trigo equation. So this trigo equation, we have 3 unknowns. One is A, B, and C. But to draw out a trigo graph, let us follow this arrangement. Okay, so let's start off with B first, and then followed by A, and then followed by C. Okay, so let's start off with the first unknown, which is B. So what is B? B is the number of 360 degree cycles of the trigo function. So now we are drawing the tan graph, right? So let's look at what is the graph for 360 degree for tan. Okay, so let's say this is the x-axis and this is where y equals to 0. So this graph will start off from the x-axis and then goes to the top, right? And then it will start from the bottom again and then intersect the x-axis and then goes up again. And then it starts from the bottom and then stops at the x-axis. So this stopping point is actually 360 degree. So this is the 360 degree cycle for tan graph. Alright, so this value of b here, according to our equation here, it's 1, right? So we assume that x is a and the value of a here is 1, which means that we are just going to draw one cycle of this graph, right? So we just need to draw out one time. So what I'll be doing now is to draw out a sketch first, then later on, once we finalize the sketch here, then we will draw the graph at the bottom, alright? So again, let's assume that this is our x-axis, or when the y value is 0. So we draw the graph one time only. Okay, and don't forget, there are some parts in the tan graph where it doesn't touch, which is these two lines, right? The 90 degree line and the 270 degree line. These two lines are called the asymptotes, right? Asymptotes are the lines where the graph does not touch, as you can see here, right? It does not touch these two lines. So why it does not touch? Because if you put 90 degrees and 270 degrees inside the equation here by using your calculator, you won't get any value. Reason is because it is undefined. It can be very big value or a very small value which we don't know. Okay, so this would be our tan graph, and make sure that the lines does not touch the asymptotes. But before we go to the next unknown, which is a, we have the modulus here. Right, so how do we draw out this modulus inside the graph here? Alright, so let's recall back modulus. So modulus would be changing negative values to become positive values. So where are the negative values inside the graph here? Alright, so what we know is for the graphs, for the part of the graphs which is above the x-axis, right? Above the x-axis, which is this part to here and this part to here, all of them are positive values. Which means the part of the graph which is below the x-axis, all are negative values, okay? Just here and here, right? So these are the negative values that we need to change from negative to positive. But how do we do that? Alright, so let's assume that this x-axis line is the mirror and this part of the graph is the object. So according to the mirror here, we draw out the image, right? So since this is the mirror, which means that the graph for this part of the graph and this part of the graph would be something like this, right? From the bottom, move to the top, where the x-axis here is the mirror. Okay, from the bottom, move to the top. Right, so this is the effect of the modulus. Everything from the bottom go to the top. Alright, so now let's go to the second unknown. Okay, so second unknown, which is a, is actually the minimum or maximum value of the graph. But for tan is a bit special because, okay, if I go back to the original graph of tan, alright, this one, as you can see, there is no maximum or minimum value, which we don't know because this graph can go straight to the top or this graph can go straight to the bottom. And the maximum and minimum value is either very big or very small, can go up to infinity. Okay, so that's why for the value of a for tan, it doesn't have any effect. Okay, and a value of a here is also 1, so we can just ignore it, right? Because it doesn't provide any value, because tan graph does not have minimum or maximum values. Okay, and for the value c here is the axis of symmetry. Okay, axis of symmetry means that, okay, let me go back a bit. Right, axis of symmetry means the middle line of the graph, which is the x-axis. Okay, so if you see this equation, right, the value of C here at the back is nothing, which means the value of C is 0. Alright, the value of C here is 0. That's why the middle line, which is the axis of symmetry, is 0, where y equals to 0. So this would be our first trigo graph, right? So let's us move this graph to our graph here. Okay, so make sure that the x-axis is A, don't write X, because here all the things here are in A. Okay, and also don't forget to label the line. So when we label the lines, make sure it's exactly the same given in the question, okay, which we are going to write out this thing here, right? Exactly the same as the question. Do not write out this one, right? Even though it is like more simple and we know it's tan A, but we just follow the equation given in the question. Alright, and also don't forget to label the asymptotes of this tan graph and make sure you label the A values or the X values lah. Okay, so here you can see everything is in pi because in the question itself, it's from 0 until pi. Pi is in radians, so everything here needs to be in radians. Okay, that's why this 90 degrees, if I convert it into radians, is pi over 2. And for the 270 degrees here, actually we need to convert, but we don't need to. Because if you recall back, this graph we just need to draw until 180 degrees only. Okay, so meaning for this part of the graph, later I will erase it. So there is, I would say no usage if we convert it here. Okay, so I'll leave it blank. And how about this pi? Why is the pi here? Alright, let's go back to the original graph of tan. Okay, here. So if I split this graph by half, right? Okay, I split it here. So this part is actually 180 degrees, which is half of the graph, right? Because the entire graph is 360 degrees, so divide 2 is half of the graph, which is 180. Which is why here I label it as pi. Okay, in radians. Right, so let's go to the second graph that we need to draw, okay, which is y equals to cos A plus 3 over 4. Okay, so let me remove this part a bit. Okay, so let's follow the cycle again. B, A, and then C, right? So B is a number of 360 degree cycle, but this time we are drawing for cos, right? So let's say this is the x-axis and where y equals to 0. So this cos graph will start from the top, go to the bottom, and then go to the top again. Alright, so since the value of B here is 1, right, we assume A is X, so the value of A here is 1, so we are just going to draw out this graph one time. Okay, and let's go to A. A is the minimum or maximum value. So we know that for cos, the maximum value here is 1, and the minimum value here is -1. Okay, and according to our equation here, the value of A is 1, right? So this means that we don't need to do any changes on the maximum and minimum value. So what do I mean by changes is, okay, if let's say, right, okay, let's say the value of A is 2, this means that the maximum and minimum value, I need to follow the value of A, which means the maximum here would be 2 and the minimum value would be -2. But since according to our equation here, A is 1, so we just follow 1 and -1. Alright, so this will be our maximum and minimum values. Right, and then we go to C. So C is the axis of symmetry or the middle line of the graph. So here it's 3 over 4. So this means that for the middle line here, we need to change the value. So from 0, we need to change to 3 over 4. Okay, so for the maximum and minimum value, we also need to change their values. Okay, so for the 0, we added 3 over 4, right? So for the two values here, both need to add 3 over 4 also. Okay, so add 3 over 4, here will become 1 and 3 over 4. And the bottom here, when we add 3 over 4, it will become negative 1 over 4. Okay, so for the x-axis, it will be from here and then it will go down a bit. Okay, because the 0, it should be somewhere between 3 over 4 and negative 1 over 4. So it will be somewhere here. Right, so these two parts would be the parts where it intersects the x-axis. Okay, so now we have this graph ready, then we draw it here. Okay, so make sure that the graph touches the x-axis at these two bottom points. Alright, not the top here, but below here. This part and this part. Okay, as you can see here, this part and this part. Here and here. Here and here. And don't forget to label the graph. So according to here is y equals to cos A plus 3 over 4. So we're going to follow exactly the same. And then we are going to label the y values. Okay, which is this one, and this one here. Right, so for the top here, it will be 1 and 3 over 4. So 1 and 3 over 4 will be here. And this is 3 over 4 would be the middle line of the graph. Okay, so it will be in this line. Okay, and then bottom will be negative 1 over 4, which is will be reaching here. Okay, so maximum value, minimum value, the axis of symmetry or the middle line of the graph. Okay, so now we are drawing it until the 360 degree, right? So now according to the question, we only need to draw until 180, which is also pi. So everything which is after pi, we can just erase it. Okay, very simple. So usually for this kind of questions, I will always recommend students, it's okay, we just draw until 360 degrees first, then only change it to the to what the question wants. Okay, which in here is 180. Right, so from the full graph, then you just rub out the parts that you don't want, which will be very simple and fast. Okay, and now let's go back to the question's objective, which is to find out the number of solutions, which is also the number of intersection points. Okay, so if we look here, okay, let's follow the second graph. Okay, so from here, okay, we have found one intersection point, which is here. Okay, and let's see it has other points or not. Okay, there's none. So our number of solutions here would be 1. Next question coming from the chapter functions, and in part A, we are given these two functions, f of x and g of x, and then we need to find the values. Okay, so notice the s at the back. So this means that we need to find more than one answer for x. And we need to find the answer according to this equation. Okay, so to solve this question, why don't we start off with this equation? And if you notice on the left hand side, we have a composite function. Alright, so recall back what is composite function. So composite functions are functions that have two or more functions combined. Okay, and to read a composite function, we should start from the inside. So here will be f first, then only g. Okay, so now we have this composite function and we have the individual functions here. So what we can do is to substitute it inside the composite function. Okay, so again, to start substituting, we should start from the inside because that's how we read composite functions. Start from the inside. Okay, so for f of x, very simple. We are just going to use the value of f of x and then just substitute inside here. Okay, so it will be something like this. Alright, and then for this one, how do we substitute g? Alright, so let's go back to the g function here. Okay, so this means that if I have x value, I put inside g, then this would be the output, 2x plus 1. So the output is according to the value inside the bracket. Okay, so here, since it's x, then here will be x. So if I change the value inside the bracket, for example, I change to this value, modulus 3x minus 7, so the things on the right side will change as well. Okay, so meaning all the values of x here will change to this. Okay, so if this is my new value of x, then the output would be 2 with the new value of x, modulus 3x minus 7, and then the plus 1 at the back. Okay, so this is how we substitute the functions. Alright, and to find out the equation of it. Okay, so now it's just manipulation here and there only. So what I'm going to do is to move the plus 1 to the other side. So here will be 11 minus 1 will be 10. And then the 2, I move it to the other side. So 10 divided by 2 is 5. Okay, and then for the next step is to move the modulus to the other side. Okay, so if we move it to the other side, means that plus and minus will be moved. Which means that this equation will have two versions already. So one is the positive version and the other one is the negative version. Okay, so this one please take note. If we move modulus to the other side, we will get two versions of the equation. The positive one and the negative one. Okay, so now for each equation, we find the value of x by moving everything to the right side. Okay, so now you can see that we have two values of x, which is why in the question it says values of x, because we have more than one answer for x. Alright, and these two will be our answers. X equals to 4 and x equals to 2 over 3. For the next part, here we have an arrow diagram and we are given two functions here. So let's go through it one by one and let's find the relation between the diagram and the two functions here. Okay, so from the diagram here, what we know is if we put 2 into h, then the output will be 13. And if we put 13 into k, then the output will be 23. Right, so this is the meaning of this diagram. And if we look at the first function here, h of x equals to 2x squared plus p. So this means that if the x I put into h, alright, so let me put the x here. If this value of x I put into h, then it will come out with 2x squared plus p, which is the thing on the right hand side. Okay, so why did I put 2 and x on the same side? Because these two things are put into h, right? And then 13 and 2x squared plus p I put together because these two things are the outputs of the function h, which means that x here is equals to 2 and 2x squared plus p will be equal to 13. Alright, and for the second function, hx equals to 4x squared plus 7. So this is a composite function, so we to read it from the inside first. Okay, so meaning the x here, it's put into h first, right? So this is the one of the things that is put into h also, so I'm going to put it here. Okay, so this x put into h, and then the output of h, right? The output of h, then it's put into the second function, which is k, right? So put into the second function k, and then it will produce out the things on the right hand side, which is 4x squared plus 7. Okay, so this is how we understand the diagram and the functions here, and to relate these two things. Okay, so now we need to find out the value of p, and then we need to find out the function k in terms of x. So this means that we need to find out k of x, and then on the right hand side, everything must be x only. Okay, so let's start off with the first thing, how to find the value of p. So this is very straightforward because just now we have mentioned that if x here is equals to 2, 2x squared plus p equals to 13. Okay, so we are going to use this two information to find out the value of p, right? So since we know that x is equals to 2, then I'm going to substitute the 2 inside here, the x, then I move this thing to the right side, then I can find the value of p, which is 5. Alright, so now how do we find the function of k, the function which is outside of this function? Okay, so let us write out the composite function first, and let's substitute the h of x function inside this equation. Okay, so here will become 2x squared plus 5. Okay, so 5 here is the new value of p. So what is the next step? Okay, so for here, there are a few steps that you need to memorize, but I want to help you all to memorize even better, so I'm going to apply this using a thing that we do all the time, which is washing clothes. Right? So for this equation, you can see that there are things inside the function, right? So let us assume that there is one shirt where the inside of it is dirty. Okay, inside of it is dirty. So our objective here is to clean this shirt. But how do we do that? Right, so first thing we need to prepare something, right, which is the soap. Right, we need to prepare a soap to clean it. But what is the soap in our situation here? Okay, so this one will be a bit special. The things inside the function would be our soap. Okay, so to do that, let me use this to become one unknown. Okay, so we are going to let y equals to the things inside the function. Okay, so this would be our soap. So now we have everything prepared already. Let's go through the steps. So the first step is to flip the shirt inside out, right? To access the things which are dirty on the inside, right? To flip the shirt inside out. But here, what are we flipping? So what we are flipping here is the things inside the equation that we have created just now. So on the left hand side, we flip from y to x. Okay, so meaning x will be on the left hand side, everything else to the right hand side. Okay, so we are flipping the things on the left hand side from y to x. Okay, so now let's go to the second step. Second step, of course, is to apply the soap to the shirt. Right? So we are going to apply these two equations that we have created just now inside this equation. Okay, so this means because here we have 2x squared plus 5, right? And we also said that y equals to 2x squared plus 5. So the things on the left hand side, we are going to change it to y. Okay, so for the left hand side, it will be k of y. And how about the right hand side? Okay, so here there's this x squared here, which in the equation that we have created, we also create an equation for it. X squared equals to y minus 5 over 2. So this means this x squared, we need to change it to y minus 5 over 2. Okay, so now notice why I didn't move the square to the other side, because we have a x square already. Right? We have an x square already. So we don't need to move this square to the other side, and then we later on cross off here and there, and then it like make the entire thing complicated lah. Alright, so I just remain the square here, so I can directly substitute this entire thing to become this. Okay, so now we can just simplify the things on the right hand side. Okay, so here will be 2y minus 3. And now we go to the third step. So once we clean it already, of course we need to flip it back, right? So just now we flip y to x. So now we are going to do the same thing also. Y to x. Flip all the y's to x. Okay, and this would be our k function. Alright, so k function will be k of x equals to 2x minus 3. Next question coming from vectors, and here we are given the map of the treasure hunt program, which is in the shape of a parallelogram. Right, so this is very important. Okay, so the parallelogram here is A, B, C, D. Okay, this shape. And we know that for parallelogram, these two lines will be parallel, these two lines will be parallel. Okay, and here it says there are 4 stations to complete this program, and then participants will start from A to D. And now in part A, we need to figure out the route from A to B. Okay, so A is here and B is here. Okay, so how do we go from A to B? Well, first thing first, let us highlight the lines that has vectors first. Okay, so it will be very easy for us to find the vector from A to B. Alright, so here it's very obvious that we have the vector for line AC and the vector for line AD. But since we just now mentioned that the line AD and line BC are parallel, which means both of these lines have the same vector. Okay, so means that for line BC we also have the vector. So now we can easily find the vector from A to B. Right, but first thing first, to find out the route, we need to set our route first. We need to figure out the direction. How do we go from A to B? Okay, so let us assume that we are here. So how do we go from B? Sorry, how do we go to B? So we can go using the lines which are highlighted. Because the lines which are highlighted, we have the vectors already, right? So we can go from A to C, and then from C to B, okay, to reach B, right? Very simple. A to C, and then C to B. And let's input the vectors that we have from the two vectors that we want lah. Right, so for A to C, it will be 15i plus 9j. And for CB, we are going to the left direction, right? But if you look at the vector of this line, right, okay, that because BC is parallel to AD, so we are going to look at AD, okay? So if you see, it is going to the right side, but we are going to the left side. Okay, so now you can see we are going opposite directions. So for opposite directions in vectors, we need to add a negative to the vector, right? So this means that for the 12i plus 5j here, which is the vector of line BC, because we are going to the opposite direction, so we need to put a negative to the vector. Okay, so minus 12i plus 5j, right? Because we are going to the opposite direction, that's why we need to put the negative here. Okay, so once we simplify this thing, then we can figure out the vector AB, which is 3i plus 4j. Alright, so just now we have found the vector for line AB already, so this means that this line we already have the vector, and since line CD is parallel to AB, so this line we also have the vector already. Okay, so now in part B it says that there's another point R, which is the price giving location, and it says that this dr is equals to 3 dB. Okay, so now in part 1 we need to find out the distance. Okay, the distance from station D to R. Right, so in vector, distance is also called magnitude. So how do we find the magnitude? Is through this formula, right? Square root x squared plus y squared. Okay, but why is the formula like this? Okay, later I'll explain. But what is the value of x and y here? So value of x and y here is actually the vectors I value, which is x, and the j value, which is y. So we need to figure out the value of x and y from the vector dr first. Okay, so now if you want to find the vector of dr, it says that it is equals to 3 dB. Okay, so now we need to find out the vector dB first. Okay, so starting point is D, and then we need to go to B. Okay, so there are a lot of ways to go from D to B, but why not we choose the most straightforward way? Okay, so let's go from D to A, and then A to B. Okay, so again, we need to set our route first. So from D to A, and then A to B. Alright, so let's put in the vectors according to the vectors that we want. So dA. So here we are going to the left side, but again, the vector here is going to the right side. right? As you can see, going to the right side. So again, opposite direction, then we need to add a negative to the vector here. So negative 12i plus 5j. Alright, and then the next vector is AB, so we are going upwards. Okay, so the vector here is also going upwards, so we can just directly use this vector 3i plus 4j. Okay, and then we simplify, then we can get the values of I and j already, which is negative 27 and negative 3. Right, so to find out the distance, we just substitute the two values inside here. Okay, so this is the symbol of magnitude. Okay, so it's just two vertical lines beside the vector. Okay, so this is not modulus, yeah? This is not modulus. In vectors, if there are two straight lines, it's called the magnitude or the distance. Okay, don't mistaken it as the vector. Right, so coming back here, we put this into the calculator. Alright, and then we rename it as the square root format first. Okay, and then we find out the actual value of the distance. Okay, 37.17 units. Okay, now going back to this formula, why is the formula like this? Alright, so let's understand what is I and j first. Right, so I here is looking at whether the vector goes to the left or to the right. Right? So if we have negative 27, this means that we are going 27 units to the left side. Right? So let's say if I'm here, I go 27 steps to the left, which I'll reach here. And then for j is representing the steps I go upwards or downwards, right? So if I have a negative 3, which means that I'm going downwards 3 units. 3 steps. I'm going 3 steps to the bottom. Okay, so now if you compare the starting point and the ending point, it's actually this line, right? It's this line. So this is actually my distance. But if you see the 3 lines, if I join up them together, it is actually a right angle triangle. Right angle triangle, and we have the units of 27 here because we move 27 units to the left and then 3 units downwards, right? And then we are finding out this line's distance. Sorry, yeah, this line's distance. So if you want to find the length of one of the sides of a right angle triangle, we use Pythagoras theorem, right? Pythagoras theorem. So if you want to find out this one, what we do? These two values, we square them, right? And then we add them up together, and then we square root, right? So this is actually the Pythagoras theorem. It comes from the Pythagoras theorem, which is why this formula is something like this. You square, you add them up together, and then square root. Okay, which is what we do for Pythagoras theorem. Alright? And for the last part, we need to find out the unit vector which is parallel to dr. Right, so what is an unit vector? Right, so unit vector has its own formula and divides two things only. So the first thing is the vector itself and divided by its magnitude. Okay, so let me give you an example what is a unit vector. So let's say we focus back on this line, okay, and the vector is negative 27i, negative 3j that we have found just now, and then the length or the distance is 27.17 units. Okay, the entire length is 27.17 units. So let's say this line has shrunk, okay, shrunk into just 1 unit only. Okay, from 27.17 shrunk into 1 unit only. What would be the vector here? Okay, so we just want to find the vector where it has 1 unit only, which is why it's called unit vector, because this vector has only one unit. So we just want to figure out what is the vector here. Okay, so to do that, very simple. For the entire vector, we are just going to divide with its magnitude, and then we can find out the vector already, which is why the formula here, vector divided by its magnitude. Then we can get the vector here. Okay, so since it says parallel to dr, so we are just going to use back the answers that we have gotten in part B1 lah. Okay, so the entire vector, alright, the entire vector, and then divided by its magnitude. So here I wouldn't recommend students to put the exact value because it will be hard for you all to simplify it. So I would recommend students to use the square root version, okay, which is this one, 3 square root 82, and put it at the bottom. Okay, so now you can see very simple to simplify. So the 27 I divide by 3, so here will be 9. Okay, and then the square root here, you just remain it, don't need to change. Okay, so the denominator here will be square root 82, and for j, same thing as well. For the 3, we divide with the 3 here, so it becomes 1, and the square root 82 will remain at the bottom, and this would be your answer. Okay, so you will be asking, this answer is actually square root, shouldn't it be removing the square root? Okay, so for vectors is an exception. Okay, you can remain your square root for vectors only, yeah? For vectors only. For the other questions that does not relate to vectors, you cannot do it. And now we're going into question 8, the first question in section B, coming from the probability distribution chapter. So here in this table, it describes the mass of the lemons, and if you see in this table, we have 4 different grades of lemons, right? A, B, C, D. Okay, and then here it says it is normally distributed. Okay, so means the mass of the lemons follow the normal distribution. Okay, so for this question, we need to use normal distribution to answer. Alright, and then here it says the mean is 67.74 gram. So in part A1, we need to figure out the value of K. So K here is actually the percentage of grade D lemons. Alright, so since we already know the percentage of the other grades, and we know that for the entire farm, the percentage is 100%, right? So if you want to find K, very simple, it's just 100% minus of 20, minus of 40, minus of 30. Alright, so our answer would be 10, right? So 10 here means 10% lah. And for part 2, it says that based on this table, we need to figure out the values. Okay, so there's an error here, it should be value only because we won't have 2 values of the sigma. Okay, so what is sigma? Sigma is the standard deviation, okay, or short form STD. So if we recall back, normal distribution, we have 2 kinds of parameters. So one is mu, mu is the mean, and the other one is the standard deviation. Okay, so to find out standard deviation or to solve any kind of normal distribution question, let me introduce you all this method. It's called the 5S method, okay, to solve these kind of questions. Right, so the first S is statement. So statement here is referring to probability statement, which describes the probability of an event. Okay, so you need to have 2 things to write out the statement. One is the event, and the other one is the probability. Okay, so let's say I use this example, yeah. Let's say our X here is the mass of the lemons. So an event can be, okay, let's say X is greater than or equal to 60. The mass of the lemon is greater than or equal to 60. So this is my event. Then I need to find out the probability of this event. Okay, so let's say example, the probability of this event is equals to 0.3. Okay, so this is an example of a probability statement, and we need to write out this statement according to the table here. Alright, so let's start off with the first thing, which is the event. So event here can also is actually also possibilities. Alright, so if we look at here, the lemons are coming from 4 possibilities. Right, it can be from grade A, B, C, or D. So means we can choose either one of these possibilities or these events. Okay, but if you look at grade B and grade C, right, if you see here there is M, right, which we don't know the value yet, because in part 3 we need to find the value of M. Okay, so for this question, let us ignore B and C first. Okay, and if you see A and D, it's clear from the M, so we are safe to use this as our event. Okay, but for me personally, I would choose the events which has greater than or equal to, right? But later I'll tell you why I choose in that way. Okay, but let's say now we choose, for our event, we choose grade A lemons. So for our statement, let's write out this first. Okay, x is greater than or equal to 75. Right, and now let's find the probability. Okay, so if we look at here, the percentage of grade A lemons is 30. Okay, so this 30 is actually the probability. So here we are going to write equal to 0.3. Alright, so this would be our probability statement. Okay, so now we can go to the second S, which is search. So search meaning we need to search the parameters of this normal distribution. Okay, so we need to find out the mu or the mean first. Okay, so mean is given, which is this value, 67.74. Alright, so let me write here, mu is 67.74. But here we are finding the sigma, right? SIGMA. But since we are finding, so we cannot search it. So we are just going to put this here lah. Sigma, it's unknown, so we need to find it. Okay. Alright, so now let's go to the third S. The third S is to standardize. So standardize meaning from X, we are going to change to Z. Okay, so there's a difference between X and Z, yeah? So X here is the normal distribution. Z here is the standard normal distribution. So you all may be asking, why we need to standardize? Okay, so let me explain this when we go to the fifth S, right? The last S. Okay, so let us focus on how do we standardize it first. Okay, so from X, how do we change to Z? So we will be using this formula. Alright, so X, sorry, that's not X. Z would be equal to X value minus the mean divided by the standard deviation. Okay, so for this 75, I am going to minus with the mean, which is 67.74, and then divided by the sigma or the standard deviation. Okay, since we don't have the value, then we put the symbol first. Alright, and on the right side, nothing changes. Okay, so this is for the third S, we standardize using this formula. And for the fourth S is to sketch the graph. And this is the standard normal distribution graph. Alright, so you can see that the x-axis here is Z, and then the y-axis here is f of Z. And you will see the graph here is actually a bell-shaped curve. Right, goes up, and then once it reaches the y-axis, and then goes down. And you can compare left side and right side actually have the same shape. So this is what we know as a symmetric graph, right? Because left side and right side both have the same shape. Okay, so since it has the same shape, meaning the area here, okay, inside here, the area, both sides are similar also. Okay, so let's say the entire area is 1. So means if we want to split it, it would be, here is 0.5, and here would be 0.5 as well. Okay, so now from this statement, how do we sketch the graph here? So we need to figure out for this value, where should it belong on the x-axis here or the z-axis here. Right, so the first thing what I would recommend students to do is to look at the symbol here. So here it's greater than or equal to. You can treat it as a direction. So since this greater than is like going to the right side, so means when we are sketching the graph later, we are sketching to the right side. Okay, to the right side. The second thing here, it would be looking at the probability. Okay, the probability 0.3. So it gives you a rough idea how much you will be sketching. Okay, so 0.3 means that we will only sketch less than half of the graph, right? Because half of the graph is 0.5. Okay, so meaning, right, let's say if I think that this value is somewhere on the left hand side, right? Okay, so let's say it's here, and if you see, and then we need to sketch the right side, right? So it will be something like this. It doesn't make sense, right? Because you see, I sketched more than half of the graph already. It may be more than 0.5, but in actual, our probability is 0.3, so we cannot do that. Okay, so means that the value, the z value that we have shouldn't be on the left hand side, should be on the right hand side already. Okay, so right hand side, let's say if I choose here, okay, and then I sketch to the right side. Okay, so this area is much logical, right? Because it is less than half of the graph and we are sketching to the right side. Okay, so this would be our area, our shaded region. Okay, so this is how we sketch the graph. We need to look at two things. One is the inequality here, and the other one is the probability. Okay, two things to set your graph. Okay, and then once you sketch, don't forget to label it, right? Just labeling this line. So this line, we need to write out the value 75 minus 67.74 and then a sigma at the bottom. Okay, so now the fifth S, which is to select. So according to the graph here, we are going to select the values in the normal distribution table later, which we'll see, okay? But before we do that, we need to check our graph first. Does it satisfy these two conditions? So the first condition is the shaded area one-sided? Okay, meaning the shaded area, does it appear left side and right side, or it's just one side only? Okay, so here very obvious that it is just one side only, right? The right side of the graph. So we have satisfied this criteria. And the second criteria is the graph connects with the right end. Okay, so right end is here. Okay, so very obvious that this area connects with the right end, okay, which is why we also satisfy this condition. So since this graph, we have satisfied these two criteria, which means that we can use the table to figure out the actual value of z. Right? So let's go to the tables now. Alright, so this is the standard normal distribution table, and now we are given the probability, which is 0.30 or 30%, and we need to find the z value, the actual z value. So to do so, we need to go through these two steps. So the first step is to find the first value, which is larger than the probability, 0.3. Okay, so what I will do is I will start from the bottom and then find the first value, which is larger than 0.30. Okay, so as you can see here, it's closer to 0.30 already, and then this one would be the first value, which is larger than 0.30. Okay? Alright, so now if you compare these two values, right, there is some difference, right? Because this one is 0.15, this one is straight zeros. Okay, so the second step is to first minus these two values to find out the difference first, which is 15. Okay, and since we know the difference is 15, we need to look at the columns here right, the columns here from the same row, and we need to look at which value is the closest to 15. Okay, so here would be 14. Okay, so now we have selected our two values, 0.3015 and 14. Okay, so even though it's not exactly 15, but it's alright. We just want to find the closest value of 15. Okay, so now once we have these two values, then we can look at these three sections to find our value of z. Okay, so since we are looking at this row, this means that for section A, we are looking at 0.5. Okay, and for section B, since we are looking at this column, so the next value is 2. And for section C, because we are looking at this column, so the next value is 4. Okay, so as you can see, we have selected these three values from these three sections, and if we combine these three values, it's actually our actual z value. Okay, so this will be our actual z value, which is 0.5 to 4. And let's go back. Alright, so according to our tables here, if the probability is 0.3, our z value would be 0.524. Okay, the actual z value. So now we can compare the actual z value with the z value that we had just now. Okay, so once we change here and then we can get the sigma value already, which is 13.855. Alright, so before we go to the next part, just now there was two questions, right? The first question was, when we are writing out the statement, why did I choose greater than and equal to instead of less than? Okay, so let's assume, right, is x less than 50. So when we are sketching the graph, right, the graph would be somewhere here. Okay, it will be somewhere here. So if we go to the fifth S, right, so one of the criteria was connect with the right end. But as you can see, this graph connects at the left end. Okay, so this actually is not an issue. It's just that later on, for the left hand side area here, because the graph is symmetric, I can move it to the right side and then sketch the area or find out the area. Okay, so why I didn't choose less than is because it's giving us much more work compared to x is greater than or equal to 75. Okay, as you can see, quite straightforward. We don't need to move this area here and there. Okay, which is why I chosen this as our statement. Okay, and then the second question was why we need to standardize. Why x go to z? Okay, let me go to the tables. So this is actually the standard normal distribution table, and it follows where the mean is 0 and the standard deviation is 1. Okay, so from the distribution that we have earlier, the mean was 67.74 and the standard deviation has its own value, right? So what we did was from here, we changed to here. Okay, but why we change? Okay, let's say, right, instead of this situation, there are other situations. Okay, let's say there are other farms, and other farms have other mean values and other standard deviation values. Okay, so let's say if we don't go through this process, right? So let's say we follow this, we find the probability according to the mean here and the standard deviation here. Okay, so we can imagine that if we want to find the probability using these tables, there will be a bunch of numbers, right? And it has one table. So imagine, right, the mean here, I changed a bit, maybe 67.75. So as you know, if mean changes, then here the probabilities will change also. Okay, so means that if we follow this situation, there will be another table. And let's say we have another situation where the mean is 70. So for this one, we have another table. Okay, so you can imagine, right? If the mean changes just by a little bit, then you have another table to refer to. So you can imagine, for so many possibilities of mean, it can have so many tables already. So in order to solve this issue, right, all of the situations here, we need to standardize it first. Meaning all of the situations here, we all follow the same mean, the same standard deviation, to make sure we use the same table for all situations. Okay, which is why we need to standardize it first, to make sure all of the situations using the same mean, same standard deviation, to find the probability or to find the z according to the table here. Okay, just follow one simple table, which is the standard normal distribution table. And for part 3, it says that hence. Okay, so it's a bit weird, it says hence, so let us take note of this first. Alright, and then it says sketch and shade the area for grade B lemons, alright, grade B, on the standard normal distribution graph. Okay, so take note, yeah, this is not X, this is Z. X is normal distribution graph. Z is standard normal distribution graph. Okay, so we need to make sure the differences. Alright, so now, since this is a normal distribution question, then we are going to use the same method, which is the 5S method, to solve it. Alright, so let's start off with the first S, which is to write out the statement. Okay, the probability statement. So we do have two things. One is the event and the other is the probability. Right? So since it tells us to focus on grade B, so our event here will be this one. Okay, X is between M and 75. So this is the event, and then the probability would be the percentage here, which is 40% or 0.4. Okay, so let's use this to write out our probability statement. Okay, and then the second S is to search. So just now we have searched already. The mean is 67.74, and just now in part 2 we have found out the standard deviation, which is 13.855. Alright, and then the third S is to standardize. So standardize meaning from X we change to Z. Right? So using this formula, so let me change the color pen a bit. Okay, so Z is equal to X minus the mean divided with the standard deviation. Alright, the X value, which is M at 75, minus the mean, which is 67.74, divided with the standard deviation, which is 13.855. Okay, and for the right hand side here, let me simplify the value. Okay, so it will be 0.524, the value that we have found in our tables just now in part 2, right? And for the left hand side, we cannot simplify it because we don't know the value of M, right? So we can remake it as it is. So now we go to the fourth step, which is to sketch the graph. Okay, so this one is sketching and shading. So I will be using freehand, okay, instead of the graph that I showed just now. Okay, and then make sure you use a ruler lah. Don't use, as you can see, the lines here is like shaky. Okay, so please use a ruler. Alright, and make sure the graph where you draw it, it's symmetric. Alright, so left side and right side must have the same shape. Don't draw something like this. Okay, so for example, something like this. Okay, so very obvious that left side and right side are different shape. So you may be deducted marks for this, yeah? Okay, so make sure that your graph is symmetric. Left side, right side have the same shape. So to sketch this graph, again, we need to look at the two things. One is the inequality, okay, which is this one and this one. And the second one is the probability. Alright, so for the inequality, as you can see, Z is between these two values. So you can expect that the area that will be shading later is like the middle of the graph. Right, so it's not exactly the middle, but it's like almost at the middle. Right? And then the probability is 0.4, which means that we are also not drawing more than half of the graph, right? Because it's less than 0.5. Right? But the special thing about this is we have the Z value here, 0.524. So we can just put the Z value here first, okay? And we assume that this line is 0.524. Okay, so here, because we want to find the left hand side for this Z value where it belongs to, right? And we only need to sketch around 0.4. So we don't know for this part, right? How much is it? From 0.524 to 0, how much is the area here? Okay, so since this is describing grade B lemons, right, we can look at grade A. Because grade A are the values where it is more than 0.524, the right hand side of 0.524. Okay, so here it's 30%, which means here is 0.3. And we know that half of the graph is 0.5, so means that this part here is 0.5 minus 0.3, which is 0.2. Okay, so from 0 until 0.524, it's 0.2 only. Okay, so since we are sketching this area already, which is 0.2, so we need to sketch another 0.4 minus 0.2, which is 0.2, right? Which would be on the left hand side already. Okay, so we can assume that this part is 0.2. Okay, and then we draw it here. So this line would be the left hand side Z value, which is the m minus 67.74 over 13.855. Okay, so our area would be something like this. Okay, I already sketched, so let me remove this a bit. Okay, something like this. So this would be our shaded region. Okay, our shaded area. Alright, so now we need to find the value of m. Okay, so maybe we can go to the fifth S and then we try to select the value from the table and we need to satisfy these two criteria. Okay, but here we don't need to, because here it says hence. But why? Alright, so if you look at this graph, this y-axis is the middle line of the graph, right? And the z value here is 0. Okay, and then you focus on the sketched area here. If I use this axis as the middle line and I split the shaded area, you can see that left hand side and right hand side have the same area, 0.2 and 0.2. If they have the same area, means that if they have the same shape, which also means that this shaded area is actually symmetric. Okay, again, because the area here is the same for left side and right side, meaning they have the same shape, which means they are symmetric. The shaded region is symmetric. So what does this mean is, for the values here, the z values here, they will be the same. Because left side and right side have the same shapes. It's just that one value would be a negative value and the other one would be a positive value. Okay, so this means that this left hand side is actually negative 0.524. Okay, why we can do this is because this shaded area is symmetric. Okay, so since we know this actual z value, so we don't have to go through step 5 again. Okay, we can skip step 5. So to find the value of m, we can just equate these two values and find out the value of m, which is 60.48. And why it says hence is because this 0.524 is found from part A2. And we reused it to find the value of m. For part B, it says that this owner has already set the profit for each of the grades. Okay, so for example, for grade A and grade B, it will be 1.5 ringgit for each of the lemon, and then C and D would be 80 cents for each of the lemon. And then here it says that the total profit earned is 1548, and we need to figure out the total number of lemons sold. Right, so for solving this question, let us assume that we don't know the total profit first. And let's use the information that we have here to figure out how to calculate the total profit. Okay, so first thing first, let us denote the number of lemons sold as X first. Okay, and then let's find out the way to calculate the profit for a grade first. Okay, so let's say I choose grade A. Right, so to find out the total profit for grade A, what we need to know is how many lemons are sold from grade A. Okay, so this one, we can just use the percentage and multiply with the total number of lemons, right? So here will be 30x. Okay, so since grade A will be doing this, so the other grades will be doing it as well. Okay, so once we know the total number of lemons sold for each grade, then we can multiply with the profit when we sell one lemon for that grade. Okay, so we are just going to list down the profits. So A and B is 1.5, C and D is 0.8. Okay, so to find the total profit for grade A, it will be 30 times X, which is the total number of lemons in grade A, multiplied with the profit earned for each lemon. Okay, so same goes to the other grades as well. Alright, but for the percentage here, let me change it to decimal first. Okay, so the 30 here will become 0.3, 40 here will become 0.4, 20 here becomes 0.2, and the 10 here will become 0.1. Okay, change all the percentages to decimal. Okay, and then we can write out how do we calculate the total profit. So here I simplified my working a bit. Okay, so since these two have the same profit, so I add up these two percentages. So 0.1 plus 0.2, so here will be 0.3. Okay, and with the X here, and then multiply with its profit 0.8, and then I add up with the grade A and grade B lemons, so 0.4 plus 0.3, which is 0.7, and then the X, and then multiply with the profit, which is 1.5. Okay, and once we simplify, it would be something like this. Okay, so now going back to the question here, we already knew the total profit already, 1548. So let me put it here to form the equation, and then from the equation here, we can find out the value of X already. Okay, so we add up these two values and move 1.29 to the other side, then we can find out that the number of lemons sold is 1200. Okay, so this question, I'm not sure why it's here. This has no relation with probability distribution. Okay, so this one is just the application of how do we count number of lemons sold according to the profit. Okay, this has no relation with probability distributions. Question 9 coming from differentiation, and here we have the graph and the equation of the curve, and then it says that this curve intersects the y-axis at point R. So in part A1, we need to figure out the coordinates of R. Okay, so since this curve intersects the y-axis at this point, so this point R is actually the y-intercept. Okay, so we know that y-intercept, the x value is 0. Right, so to find the y value, very simple, it's just substitute x equals to 0 inside the equation here. Alright, so all the values that have x all will disappear except the value at the back. So this value, 16, would be our y value or the y-intercept. Okay, so don't forget to write your final answer in the coordinate format. So here will be r bracket 0, 16 bracket. Okay? And for part 2, it says that we need to find the gradient of normal at the same point. Okay, so let's recall back what is normal. So normal is a line which is perpendicular to the tangent. Right, and what is tangent? So let's recall back. Tangent is the line where it intersects one point of the curve. So that one point is point R. So example of the tangent, it would be something like this. Okay, the whole line, I just intersect at point R only. Okay, so once we know this is the tangent, then the normal is perpendicular to the tangent. So normal would look something like this. Then both of these lines are perpendicular. Okay, so now if we want to find the gradient of normal, we first need to find the gradient of tangent. Okay, but how do we find the gradient of tangent? Okay, so recall back in this chapter, what we have learned is if we want to find the gradient of tangent, we need to use the gradient function, right? Which is m equals to dy over dx. So to find out the m, we need to first find out the dy over dx of the curve. Okay, which is using the equation here. So what we need to do is to differentiate this equation to get dy over dx first. Okay, so for differentiation, what we need to do is to split all these things with the plus and the minus first. Okay, so now you can clearly see that we need to differentiate 4 things. Right, so let's go through one by one. So we are going to copy the power to the front and multiply with the value here. So in front here will be 2, and then the power will minus 1. So here will be 2x power of 2. Right, same goes to this one as well. I'm going to copy the power to the front and multiply with 9 over 2. So here will be 9, and then minus 1 with the power. So here will be 9x. Okay, and for this one, since it's just x, then I'm just going to take out the value only, which is negative 18. And since this is just a value, so when we differentiate value, 16 will disappear. Alright, so once we differentiate, this would be our equation. Alright, so now we have the dy over dx already. So if we want to find the gradient at this point, then we need to substitute the coordinates into this equation. Okay, so dy over dx, let me change to m, and then the x values, we would use it based on the x coordinate of point R, which is 0. Okay, and then to find the gradient of the tangent, which is negative 18. Okay, so now we have the gradient of tangent already. Now we can find the gradient of normal. But this is perpendicular. So how do we do that? Okay, we need to take back something that we have learned in the coordinate geometry chapter, which says that the gradient of both perpendicular lines, if I multiply together, it will be equal to minus 1. So since now the perpendicular lines is tangent and normal, so let us assume that m1 is the tangent and m2 here is the normal. Okay, so for the negative 18, I am going to substitute it here, the m1, and then I move the negative 18 to the other side, and then I can find out the gradient of normal, which is 1 over 18. For part B, it says that we need to use the second derivative, and then to show that Q, okay, so Q is here, that Q is the minimum point. So quite obvious that it is the minimum point in this graph, but how do we use the second derivative? Or what is the second derivative in the first place? Right, so second derivative, it's the d square y over dx squared. And if you remember back, there are some certain conditions to indicate that if let's say this thing is greater than 0 or less than 0, it would be some point. It can be a maximum point or minimum point. Okay, since we are touching on this, let us recap back the things we have learned in this chapter. Alright, so we have 3 kinds of points. One is called the minimum point, maximum point, and inflection points. Okay, So this inflection point, I think not much of students know this because quite rare to come out in exam, but it may come out. So an inflection point is actually, okay, let's say we have something like this, right? Okay, the curve is something like this. There is one part here, it's like quite stagnant, quite stable. It's like a straight line almost. So if we have a point here, this is actually called an inflection point. But how do we identify this point is, okay, so these 3 points, they are also called stationary points. And why they are called stationary points is because the dy over dx, or the gradient, which is m, is 0. Okay, so if let's say we go back to Q, right? If we want to draw a tangent to this point, it is a straight line, right? Okay, the tangent for this minimum point is a straight line, which is also m equal to 0. So same goes to the inflection point also. If you want to draw the tangent at this point, it will also be a horizontal line. Okay, which also means that the gradient is 0. So the common thing for all these 3 points, which is also called the stationary points, their dy over dx is 0. But how to determine them is through the second derivative. Okay, so for minimum point, it will be greater than 0, maximum point will be less than 0, inflection point will be equal to 0. Okay, so this is how we differentiate the stationary points. But before we find d square y over dx square, there's one issue, which is we don't know the coordinates of Q. So if we don't know the coordinates of Q, then when we are finding the value for second derivative, it will be very difficult. Okay, so we need to find out the coordinates of Q first. So how do we do that? So as we know, Q is a minimum point, and we know that for minimum point, the dy over dx is 0. So what we can do is we're going to use back the same equation that we have gotten in part A, and then we change dy over dx to 0 first. Alright, and then from here you can see that it is a quadratic equation, so we can use factorization to figure out the two values of x using the calculator. Okay, so once you have put into a calculator, you will notice that there will be two values of x, 3 over 2 and -6. Okay, so we need to reject one of it because we have only have 1 point, and it's quite easy to reject which of the x we don't want, because as you can see, this q is on the right side of the graph, which means the x value for q is a positive value. So which means we need to reject x equals to -6. Again, because our x must be positive. Okay, so once we have the x value already, then it would be great for us to find the value of d square y over dx square. Okay, so now let us differentiate this equation to find d square y over dx square. Okay, so the same thing, I am going to separate this equation by the positive and negative here, the plus and the minus here. So clearly you can see we need to differentiate 3 things. Right, so use back the same technique. We are going to copy the power to the front. So we multiplying with 2 here, so 2 times 2 will be 4, and minus with the power here. So here will be 4x, and here is just x only, so we just extract the value of the x, which is 9. And for -18 here, because it's just a value, when we differentiate, it will become 0. Okay, so our equation for d square y over dx square is 4x plus 9. And just now we have found the value of x, okay, the x coordinate for q, then we can just substitute it here and then find the value. Okay, so here it's a positive value. So we know that for positive value, it is a minimum point. Okay, so we have proven that using the second derivative, q is a minimum point. Okay, so we can write out a final conclusion here. We can say that Q is a minimum point. And for part C, it says that we need to figure out the percentage of the approximate change, alright, approximate change in f of x if there is a small change in x by 0.03 when x equals to 5. Okay, so what does this question mean? Okay, so originally x was 5. Okay, and then there was a small change in x by 0.03, which means the new x value is 5 plus 0.03, which is 5.03. Okay, so x changes from 5 to 5.03. So if we change the x, of course, the f of x value will also change, right? So we need to figure out the change. But there's another thing, for the change here, we also need to change it to the percentage format. Okay, so in this sentence itself also have some keywords. For example, approximate change and small change. So if you see these kind of keywords, it relates to the last application in differentiation, which is the small changes and approximation. And we need to remember these two formulas, which will be very useful when we are solving these kind of questions. Okay, so let's go through the formulas one by one. So for the first one is delta y over delta x. Right, so this symbol is called delta, D-E-L-T-A, and these two, if I divide, it will be approximately equal to our dy over dx, the differentiated equation from the equation y. Okay, so we know dy over dx, but what is delta y over delta x? Right, so delta y itself is the small change in y. So means how much does y change? Okay, so for delta x, it will be small change in x. So let me give you an example for delta x. So just now for x, it changes from 5 until 5.03. So how much did it change? It changed around 0.03. And this 0.03 is actually our small change, right? Small change in x. So this delta x would be 0.03. Okay, so now in the question here, we need to figure out delta y, the small change in y, and we need to change it to the percentage format. So how do we do that? Well, we need to look at the second formula. So this is the percentage change in y, and we use the delta y from the first formula. Alright, so these two are the same. These two are delta y. Right, so delta y over y. Right, so the y below here is the original y. Okay, original y, and we need to multiply 100% to get the percentage change. So you may be asking, why delta y is over y? So let me give you an example. So let's say we have this cake here, right? And then I take out a piece of the cake, which is here. So of course, when I take out this piece of the cake of the shape changes, right? So now I want to know how much did the cake change, or meaning how many percent of the cake that I took out, right? So this one very simple, right? It's just the area of the piece of the cake, right? The area of the piece, and I divide with the area of the whole cake, right? The piece of the cake divide with the whole cake. So you can imagine that y is the whole cake, the original value of y. Then for the piece of the cake here is the delta y, because delta y is the part of the y that changes, right? So this piece of the cake will be delta y. So if we want to find out the change, the percentage change, then it would be delta y over y. Okay, which is why in the formula it's in this way, delta y over y times 100%. Okay, so now if we want to find out the percentage of approximate change in f of x, which is y, then we need to start off using this formula first. But before that, let's gather all the information that we have from the question here first. Okay, so here it says small change in x, which we already know is delta x. So delta x would be 0.03, and then we have x equals to 5. Okay, so now let's use the formula of the percentage change in y to solve this question. Alright, so to find delta y, again, we need to use the first formula, right? Delta y over delta x approximately equal to dy over dx. Okay, so if you want to find delta y, means that I need to move this delta x to the other side. Okay, so it would be something like this. So dy over dx multiply with delta x. So means if we want to find delta y, we need to have these two things, the dy over dx and the delta x. Okay, which both of them we already have, right? Because in the previous parts of the question, we have the dy over dx already, which is this one. Okay, so we are going to put this inside here. And for the delta x, we have also already given, right? Which is 0.03, so we're going to multiply here. But delta y is a value, and if you see the things inside here, there are x. So we need to find a way to change x to a value. But which value should we use? So this one, actually you can just use the original value of x, which is 5. Okay, so we can just substitute the 5 inside here, and then to find out the value of delta y, which is 2.31. Okay, so this is the first thing that we need to find, which is delta y. Then for the bottom y here, which is the original value of y, how do we find the original value? Well, this one very simple, because we already have the original value of x. So if I use this value and I substitute inside this equation, technically using the original value of x, I can find out the original value of y, right? So we can just substitute the x into here. Okay, so this is the working. And once we substitute, then we will get y is 731 over 6. Okay, so now we already found the two things that we need to find out the percentage change by putting this into the calculator, which would be, okay, so this one I think we can change it to 3 decimal places. So 3 decimal places would be 1.896%. For the next question coming from linear law, right, so for paper 2 questions from this chapter, we need to draw the best fit line. Okay, so let's go through the question here. So here it says that the variables x and y are related using this equation, and you can see that it's a non-linear equation. Alright, and then we have the values of x and y here. So in part A, we need to complete this table. So you see for the second row, it is log base 10y. Alright, and if you look at the same value of x from this table and this table, there is the original value of y, which is 1.995. Okay, so if we want to find the new y value, if x is 0.1, then we need to substitute 1.995 into here. Okay, so the value would be log base 10 1.995, which is 0.30, and let's remain the answers in 2 decimal place. Okay, so this same goes to the other x values, alright, and remain it as 2 decimal place. Okay, next question is we need to write the non-linear equation into the linear format. Alright, so what is the linear format? So linear format is the y equals to mx plus c. But the question is, what kind of y and what kind of x are we changing to? Right? So for the big Y and big X, actually you can look at part C. here it says plot log base 10y against x. So here is x-axis is x, y-axis is log base 10y. So why not we use the same axis and to apply it here? Okay, which means the big Y here, it will be log base 10y, and the big X here would be X. Okay, so it's not just you can use part C, you can also use part A, because here it tells us to change into these numbers already, X and log base 10y. Okay, so now we know that what is big Y and big X already. So how do we change this equation to have these two things? Right, so the first thing I will always do is to compare the Y values to see what is missing. Okay, so here clearly you can see that this log base 10 is missing from here, right? So to add this log base 10, what we need to do is to apply log for both sides, right? Okay, so now you can see that both of the sides have log already. Okay, so now we need to simplify this equation a bit. So let's pull out the log formulas from our formula sheet. Okay, from formula 5 to 7. Right, so from the left hand side, you can see that y is divided by h. So if we see values which are divided in the log, okay, we can look at formula 6. So we can split the two values out. It's just that we need to put negative or minus. Right, so here will be log base 10y minus, okay, because it's divided, minus log base 10h. So this is for the left hand side. How about the right hand side? Okay, so at the power part, you can see that there is x here. Okay, but in our linear equation, the x must be not a power. Right? It's not a power here, it's a value. So how do we change this power to become a value? Well, we can look at formula 7, right? Because here it says that the power of the value, we can move it to the outside of the log, right? So the value of n would be outside of the log. So here, same thing as well. For the kx, I'm going to move outside of the log and it will appear here. Okay? And for this part, you can see that the value of the log and the base value is the same, right? So here, we need to recall back one of the very important things in logarithms, which is if the base value and the log value is the same, then it can be equal to 1. Okay, so this entire thing will become 1. Which means it will disappear lah, because 1 times kx is still kx only. Alright? Okay, so now let's compare the equation that we have and here. So left hand side will only have log base 10y. Okay, so I'm going to remain this value on the left hand side, but this value I need to move it to the right side already. Okay, so this value negative will become positive. Okay, and then here on the right hand side we have kx, and on the right side we also need an x. Okay, so this kx we can remain on the right hand side, so means we just need to change log base 10h to the other side. Alright, so now once you have this one, you can clearly see that it's y equals to mx plus c. So big Y is log base 10y, big X is x, small x, m, which is the gradient, is k, and c here is the log base 10h. Okay, so this is how we change from non-linear to a linear equation. Right, so the very crucial thing is we need to figure out what is the big Y and the big X, and you can find it from part A or part C. Okay, so going to part C, now we need to plot this graph, which is the y-axis must be log base 10y and the x-axis must be small x, and then we need to use this scale 2 cm to 0.1 units on both of the axes, and we need to draw the best fit line. Okay, so let's go to the graph and draw out this best fit line. Okay, so this would be our graph paper, and the first thing is to label the axes, okay, the x-axis and the y-axis. So how do we label it? We are going to look at this one, right? Log base 10y against x. So this means that for the y-axis would be log base 10y, alright, and then the x-axis would be small x. Alright, and how about the scale of the axis? Well, we need to look at this sentence, right? 2 cm to 0.1 unit on both axes. So where is the 2 cm? Right, so 2 cm is basically the length of this big box. Okay, this big box. So the length here is 2 cm. So if you want to confirm, actually you can use the ruler, your own ruler, to measure the length. You will see that it is 2 cm. Okay, so here it says 2 cm for every 0.1 unit. So that's why here I put 0.1. Same goes to the y-axis as well. Alright, and then if you want to find the other values, very simple, we just add 0.1 to get the next value, 0.1 to get the next value. Same goes for the y-axis also. Okay, 0.1 plus 0.1 get 0.2 and so on. Okay, so now to find out the best fit line, what we need to have is the points, right? So the points, we can actually get it from the table in part A. Okay, so here we already have the x coordinate and the y coordinate for these 6 points. So we are going to plot these 6 points inside here. So now we have already plotted the 6 points. Okay, so once we plotted the points, then we can draw out the best fit line. Okay, so let me take out my ruler here. So to draw the best fit line, we have 2 rules that need to follow. So the first rule is to pass through as many points as possible, right? And the second rule is for those points that did not pass through, we need to see whether the points which are above and below our best fit line, is it almost the same or not? Okay, so let's go through our first rule and let's see how many points that we can pass through. Okay, so if I adjust my ruler here and there, most likely it's just 4 points, right? 4 points, which is the first, second, fifth, and the 6th point. Okay, so you can see that for the third and the fourth point, we didn't really intersect, right? Third one and the fourth one here, behind the ruler. Okay, so 4 out of 6, I would say is a good sign. It's a good result. Alright, so let's go to the second rule, which is from the best fit line that we're about to draw, and those points that did not intersect our best fit line, we need to see the points which are above and below the line, is it similar or not. So for our case, we can see that 1 point is above the line and 1 point which is below the line. So above and below, we have the same amount of points, which means we have satisfied the second rule. Okay, so we can draw our best fit line. Alright, so a few tips here. So for the best fit line, make sure you intersect the y-axis. Okay, why do I say that? Because if you look at part D1, right, find the value of h and k. So according to the equation that we have gotten in part B just now, h is actually under the y-intercept. Alright, so since we don't know what is the value of the y-intercept, so we need to find it from this graph. That's why here we need to draw this line until it intersects the y-axis, because we can find the y-intercept. And once we have the y-intercept, we can compare with this value to find out the value of h. Okay, so make sure to pass through the y-axis when you draw the best fit line. Okay, so now we have drawn our best fit line, then we can go to part D already. Right, so for the first part, we need to find the value of h and k. So for these kind of questions, right, usually we need to see for the h and k, where does it belong to? So how do we know where it where does it belong to? We need to look at the equation that we have gotten in part B. Okay, so h, just now we have mentioned that h is from the y-intercept, right? And the value k here is the gradient. Okay, so since in the graph here we already intersected the y-axis, so it's quite easy that we can find the y-intercept. Okay, so let's start from finding value of h first, okay, because h is inside the y-intercept. Okay, so if we zoom in here, I think very clear that the y-intercept is 0.2. Okay, so what we are going to do is, okay, let me move up a bit. Alright, so to find the value of h, we need to compare the y-intercepts from the equation, which is log base 10h, and the y-intercept from the graph. Okay, and then we can find the value of h. But how do we find the value of h? Because the log is here. Alright, so remember the 3-step method to solve any kind of logarithm question? So recall back the third step. So third step is to change the form. Alright, so meaning log ay equals to x. Okay, so now we are at the logarithm format. So now what we need to do is to change to the index format. So how do we do that? Very easy. It's just the a, we push it to the other side. So here will be a power of x. So here, same thing as well. The base, we are going to push it to the right side. So here will be h equals to 10 to the power of 0.2, which will be 1.585. Alright, so this is the value of h, and now let's find the value of k. Right, so k here is the gradient of this line. So back to the graph here, we need to figure out the gradient of this line. Alright, so how do we do this is, firstly, choose 2 points which are on the best fit line. Okay, 2 points which are on the best fit line. Do not choose the points that you have plotted just now. Okay, you cannot choose this one, and you cannot choose this one. You cannot choose the ones that is also on the line. Okay, so to choose those 2 points, usually I would choose them as far away as possible. Okay, so here, and also what I will do is, usually I will choose the points which are on the thicker lines, because it's easy to find the x coordinate and the y coordinate. Right, so here what I will do is I will select this point, because it is on the thicker lines, which will be easy to find the coordinates. Okay, so if I zoom out a bit, the coordinates here would be x is 0.7 and y is 0.9. Okay, so let me label a bit. So this one is 0.7, 0.9. Okay, and then here I try to find another point which is far away as possible from this first point, and then I find the point which are on the thicker lines. Okay, let me see. Okay, maybe this one. I think this one is good. Alright, so the x coordinate here is 0.3 and the y coordinate here is 0.5. So let me label this first, 0.3 and 0.5. Okay, so now we have these 2 points. Then technically we can use these points to find the gradient. Okay, but before we do that, we need to do something in this graph. Right, so what we need to do is we need to draw out a right angle triangle. Okay, so how do we draw the right angle triangle? So basically is using your ruler. Alright, using your ruler, draw a horizontal line here. Okay, so here you can use a dotted line lah. Okay, so I'll be drawing a dotted line and a vertical line here as well. So you may be wondering, why do we need to draw this right angle triangle? Shouldn't we just calculate the gradient from these 2 points and that's it? We don't need to draw this triangle. Alright, the main reason why we need to draw this triangle is because we want to prove that this part of the line is a straight line. Okay, but how does a right angle triangle prove that this is a straight line? So if you remember, right angle triangle follows Pythagoras theorem, right? And Pythagoras theorem works if this is a right angle triangle and also these three lines are straight, right? These three lines are straight, which includes the line that we are trying to prove. Okay, so why do we need to draw this right angle triangle? Because it helps us to prove that this is a straight line through Pythagoras theorem. Because Pythagoras theorem says that all these three lines must be straight and then must have a right angle here. Okay, so now once we draw the triangle already, then we can calculate the gradient. Okay, so let us go back to here. Alright, so from the 2 points that we have collected just now, which are 0.7 and 0.9, okay, 0.7 and 0.9, and the other one is 0.3 and 0.5. So if we want to find out the gradient, so it will be m equals to y1 minus y2. So let's say this is the first point, this is the second point. So y1 minus y2 over x1 minus x2. So here, once I put this into the calculator, you will get 1. Then the value of k is also 1. Alright, so we have found the value of h and k already. So now in part 2, it says that we need to find the value of y when x equals to 0.55. Okay, so let's see if x is 0.55, what is the value of y? Okay, so let me pull out the ruler again, and I'm going to put at where x is 0.55, okay, which is this line. Alright, so when we zoom in here, okay, you can see that the ruler and our best fit line intersect at this point. Okay, so here we need to find the y coordinate of it. Alright, so let me adjust the ruler a bit, and our y value here is the middle of 0.7 and 0.8, which is also 0.75. Okay, so our y value is 0.75, but is this our answer? Is our y value 0.75? We need to double check our y-axis. Okay, recall back, our y-axis here is log base 10y. So this 0.75 is not our y value, but is the value of log 10y. Okay, so let me remove this ruler and let's go back to our workings here. So log base 10y is equals to 0.75. So now if we want to find the value of y, then we can use back the same rule that we have used in part D1 just now, which is this one. Okay, from the log form, we change to the index form to find the value of y. Okay, so here, right, so here we just move the base to the other side. So here will be y equals to 10 power of 0.75, and when you type this into calculator, you will get 5.623. Okay, and this would be our answer. And the last question in section B, coming from coordinate geometry. So here we have a right angle triangle, and in part A, we need to find the value of k. So value of k here is the x coordinate of point B, where k is less than 5. Alright, so according to this question, the only thing that we know that this is a right angle triangle, which also means that line AB and line BC are perpendicular. Alright, so since we have perpendicular lines, why not recall back the things that we have learned in this chapter, which relates to perpendicular lines. So one of the information that we know is if we multiply the gradients of perpendicular lines, it will be equal to -1. Right? So since we have the perpendicular lines here, why not we use this formula and to find the value of k. Alright, so meaning for M1 here, I'm going to find the gradient of line AB, and for the M2 here, I'm going to find the gradient of line BC. Okay, then if these two values are multiplied together, then will be equal to -1 according to this formula. Right, so let's do that. So to find the gradient of AB, we are going to recall back the gradient formula. So let's say B is the first point, A is the second point, so y1 minus y2, which is 0 minus 8, then divided by x1, which is k, minus x2, which is -2. Alright, same goes to line BC also. B is the first point, C is the second point, so y1, which is 0, minus y2, which is 4, and then divided by x1, which is k, minus x2, which is 10. Okay, so once we have this, let's simplify it. Alright, and then I'm going to move the denominators to the other side, and the numerators here, I'm going to multiply together, so it will be 32. Okay, so once I move these two to the other side, they will still be negative. Alright, so here I need to cross multiply the values first, and then for each of the values I need to multiply negative. Alright, so you'll get this result, and then for all of these things here, I'm going to move it to the left side, and you can see that we have formed a quadratic equation. Okay, so if we see quadratic equations, then we can factorize using the calculator to find the two values of k. Right, so here you will get k equals to 2 and k equals to 6 as your answer. Right, but here we only want one value of k because we only have one x coordinate. Okay, so remember, here it says k must be less than 5. So this means that we need to reject k equals to 6. Okay, because it's not less than 5. So our answer will be k equals to 2. For part B, it says that we need to find the equation of the shortest path, alright, shortest path from point B to straight line AC. Okay, so let's imagine we are here, we are at point B, and then we need to reach line AC. Okay, so it can be somewhere here or any part of the line lah. Okay, and then let's imagine if you want to go from B to AC, there is a road, and cars will be passing through here and there, and let's assume that this line AC is the other side of the road. Right? So if we are at point B, what is the fastest way to pass through this road and reach the other side, or line AC? So of course, the fastest way would be to run or walk straight towards line AC, or the other side of the road, right? We won't be walking at a tilted line, for example, something like this, or something like this, right? We walk straight, because if you look at the other two lines, it's longer. Okay? And another thing you will need to notice is, if you see the direction you have walked or run just now, it is actually perpendicular to the road. So this means in questions, when you see shortest distance, then technically you can link it to perpendicular already, right? Because shortest distance is related to perpendicular, for example, in this situation. So we want to find the shortest path to go from B to the other side. So our direction would be walking straight towards, right? Not tilted, walking straight towards line AC. So when we walk towards line AC, then technically line AC and the direction that we have will be perpendicular to each other. Alright, so now we need to figure out the equation of this line. So to find the equation of any line, we just need to have two things. One is the gradient and the other one is a point. Right, so the point we already have, which is point B, but we don't know the gradient of this line. But since we do know that this line is perpendicular to line AC, so why not we find the gradient of line AC first and then use this formula to find the gradient of the other line. Because again, these two lines are perpendicular. That's why we can use this formula. Right, so let's find out the gradient of line AC first. And we can use the formula. So let's say this C is the first point, A is the second point. So y1 minus y2, and then x1 minus x2. Okay, and then you'll find that the gradient is -1/3. So we can substitute this -1/3 inside this formula. But here, let us label this line first because we don't know the name of this point. So let's say we put D. Okay, so here would be the gradient of line BD. If multiplied with the gradient of line AC, then it will be equal to -1. Okay, so I'm going to substitute this value inside here to find the gradient of line BD, which is 3. Okay, so now I have the gradient and I have the point, so I can substitute into this line equation, y equals to mx plus c, and find the value of c first, okay, which is -6. Then with the y-intercept and the gradient, I can form the equation. So our equation of the shortest path is y equals to 3x minus 6. And for part C, here it says me to find the triangle ABF if BF to FC is 3:1. Okay, so since this is a ratio, why not we put this ratio in this diagram first? Okay, so BF is here, right? So here would be 3 and FC is here, so it would be 1. Alright, so if you want to find the area of any shape which is in this x and y plane or this diagram, we first need to find all of the coordinates of all the points in the shape. Okay, so now we need to find the area of triangle ABF, so means we need to have the coordinates of point A, point B, and point F. But as you can see here, we don't have the coordinate of F. Alright, so what we need to do to find the area, we first need to find the coordinate of F. And if you see, this point actually is within this line BC. And also we have the coordinates of B and C here, right? And also the ratio. So how do we use the coordinate and the ratio to find the point which is within this line? So we can go back to our formula sheet and to use this formula, which is a point dividing a segment of a line. So a segment of a line is basically line BC. Okay, and a point here is referring to point F, and you see it says dividing. Okay, so this means that this point F, I place it here, it's like I'm dividing the line BC. I split the line BC into two parts, which is one part here and one part here. Okay, that's why this formula is called a point, which is point F, divides or separates a segment of a line. So a segment of a line is line BC. So F is dividing line BC. Okay, and if you want to find that point which divides the line, we can use this formula. Alright, so if you see in this formula, there is M and N. So what are those? So M and N are actually the ratios of the line, okay, which is 3 and 1. But which one should I put M? Which one should I put N? Okay, so usually what I will do is, for the left number, I will always put M, and the right number, I will always put N. Okay, and if you see this formula, it's like nx1 plus mx2. Okay, we can follow this formula, but there's another way to look at this even easier, which I think in schools teacher will teach this also, which is to cross multiply the values. Okay, so cross multiply values meaning for the right ratio here, I'm going to multiply with the left coordinate, and the left ratio I am going to multiply with the right coordinate. Okay, so let's go through this formula and see how does this cross multiply apply here. So here start off with nx1, right? So we are going to use the right ratio and then to multiply with the x coordinate of the first point. Okay, so let's say if the first one is b, so 1 times 2. Okay, so now you can see 1, which is the right ratio, I multiply with the left coordinate. Okay, and then the other one is mx2. So m is the left ratio, so left ratio I multiply with the x coordinate of the second point, which is c. So 3 times 10. Alright, and then we are going to divide with the sum of the ratios, which is 1 plus 3. Okay, so this thing same goes to the y coordinate also. So starting from n, which is the right ratio, I'm going to multiply with the left coordinate, the left y coordinate, which is 0. And then for my2, it would be the value of m multiply with the right coordinate, the right y coordinate, which is 4. So 3 times 4, and then I'm going to divide with the sum of the ratios again, so 1 plus 3. Okay, so once you put this into calculator, then you can get your coordinates already, right? So f is 8, 3. Alright, so now we have the coordinates of all of the points of this triangle already. Then we can find the area. So how do we find the area? Is using the shoelace formula. Alright, so using this way, we are going to substitute all of the coordinates of the triangle inside here. Alright, but here to make our workings more straightforward, I will usually prefer students to use the anti-clockwise way when finding the area, because the value that it comes out will be positive. Alright, so clockwise you can use it, but it's just that the final answer, so once we cross multiply everything, the value inside the modulus will be negative. So we need to remember that the negative value we need to change to positive because of the modulus. Okay, so it might take a little bit of work for clockwise. So we always, I will always prefer students to use the anti-clockwise way lah. Okay, so now let's substitute the values using the anti-clockwise way, and to do that, let's select our starting point first. Okay, so let's choose A as our starting point. So I'm going to substitute the coordinates of A here. Okay, negative 2, 8. And then I'm going to the anti-clockwise way, right? So from A to B, and I'm going to substitute the coordinates of B. And then followed by F, which is 8, 3. And also here, don't forget, we need to go back to our original point. Okay, so this means that we need to put again the coordinates of A, right? And then we are going to close it. So the two vertical lines here are actually the modulus lah, right? So why is it called a shoelace formula? Because when we cross multiply the values inside the modulus, right, you will see there is a shoelace pattern. Okay, so what do I mean by that? So let's start off with the first group. Alright, the first group. So here we are going to multiply the top left number with the bottom right number. So basically is negative 2 times 0, 2 times 3, 8 times 8. And then we are going to add those three values together. Okay, but here for the working, I will need y'all to write all of the working out. Right, so this means here we said that negative 2 times 0, right? So we're going to write negative 2 times 0, and then we are going to plus 2 times 3, plus 8 times 8. Okay, but why we need to write this very long working? because it proves that you know how to cross multiply the values in the modulus. Okay, which will potentially give you extra marks if you write out this. Okay, and also if let's say you don't write this one, but you skip to the final answer, but you accidentally press wrong in your calculator, then you won't get any marks. So this part you have already missed out. Okay, so make sure to write out all the working to prove that you know how to cross multiply the values. Okay, so this would be the first group of values, and then we have a second group. So for the second group is basically the bottom left number multiplied with the top right number. Okay, which means 8 times 2, 0 times 8, and 3 times -2. And again, once we multiply, we are going to add them up together. So now you see this is a shoelace pattern. Okay, so means when we cross multiply the values, we need to do it in a shoelace form. Right, which is something like this. Okay, so from our second group, we need to add these 3 numbers, right? But here, from the first group and the second group, we need to minus them. Okay, so for the first group of numbers, we are going to minus with the second group of numbers. Okay, and this would be our working. So 8 times 2 plus 0 times 8 plus 3 times -2. Okay, so once we simplify, okay, so for the first group, once we simplify, it will be 70. And for the second group, once we simplify, it's 10. So 70 minus 10 would be 60. Okay, and then 60, which is here. So you'll notice that the value inside the modulus is positive. Why? It's because we are using the anti-clockwise way to substitute the coordinates inside the formula. Right? Which is why the value is positive inside the modulus. Okay, so 160 divide by 2, then we'll get the final answer, which is 30. Alright, the first question in section C. So again, section C is the one that surprised me because of the sudden increase in the difficulty, but that's not the blocker for us. There are still techniques to solve this kind of question. Alright, so first question is coming from the kinematics of linear motion, and here I have summarized all the things that we need to know for this chapter. Right, so you can screenshot this first, and then when we discuss the question here, you can refer back the table. Alright, so now in this situation, we have 2 fixed points P and Q, and we have 2 particles A and B, and the distance between them is 6 meters. Okay, and in this paragraph, there are a lot of things which describes the particle A and B, so we're going to go through one by one, and the information I'm going to write it beside the particles. Okay, so here it says particle A moves through fixed point P with a velocity of -4. So what does this sentence mean? Okay, so let's understand velocity of -4 first. So if we go back to the table here, if we see velocity is negative, which means the particle is moving to the left side, right? Because now our velocity here is a negative number, -4. Alright, so this means that this particle has already been moving to the left side. Okay, so it moves to the left side until it reaches at point P. Okay, that's why here it says A moves through the fixed point P with a velocity of -4, because previously it already been moving. Okay, but for this question, let's us assume that this experiment starts when particle A is at point P. Okay, the experiment starts when the particle A is at point P. So this means that when t equals to 0, which is the start of the experiment, it has a velocity of -4. Okay, so this is the meaning of the sentence here. The experiment starts when particle A is at point P. Okay, which is why the velocity when it's t equals 0, it's negative 4. Alright, and then here it says the acceleration of particle A is 2t. Okay, so I'm going to write it here also. So this is for particle A, and if we go to particle B, okay, so here it says particle B moves through the fixed point Q with a velocity of this. Okay, so this one depends on the value of t, which is the equation of velocity for particle B. So I'm going to put it here first. Alright, so now in part A, we need to find t if the particle A stops instantaneously. So meaning it stops for a while, a very short while. Alright, so for this kind of question, we always need to ask ourselves, S, V, and A, which one is suitable for this question? So let's recall back, S here is describing the location of the particle. So means like from the origin, it is on the left side or the right side or at the origin. So S is describing the location. V here describes the movement. For example, the particle moves to the left or to the right, which is here. Example, if it's negative, then it moves to the left side, right? Right. For A describes the change of the movement. Okay, so meaning I go suddenly from slow to fast, or can be from fast to slow. So it's like the speed within the time it changes. Right, so here, since it says stops, which one is suitable? So stops here is suitable for V, right? Because stops is also a movement where V equals to 0. So stop doesn't describe the location. Stop also doesn't describe the change of the movement. So it would be V. Okay, so now means we need to find t when V equals to 0. Hey, but the issue is here in particle A, we don't have the velocity equation. We only have the acceleration equation. So what we are going to do is we are going to recall back the relationship between S, V, and A. Okay, so if we want to find V and if we have A, so to find V, we need to integrate the acceleration equation. Okay, so we are going to this direction. So now means we are going to integrate 2t here. Alright, so integration, same thing as well. We are going to add 1 to the power. So originally it was 1, then we add 1, and then we are going to divide with the new power, which is 1 plus 1, 2. Okay, so here will be 2t squared over 2. And since there is no values in the integral, okay, please take note, yeah, if there is no values in the integral, we need to add a c at the back. Alright, so the equation here would be t squared plus c. But of course, this cannot be our final answer for the velocity equation. We need to find the value of c. Alright, so here actually we have the information that we need already, which is what we said just now. The experiment starts when particle A passes through P, which is t equals to 0, and this particle A has already been moving. So the velocity of A is negative 4. So here we can substitute this information inside this equation. Okay, so the t here would be 0, the VA here would be negative 4, and then you can find the value of c, and this would be our velocity equation. Okay, so now we have the velocity equation already, and then we can substitute v equals to 0 here to find the t value. Okay, so you see on the right side is actually a quadratic equation, so we are going to use factorization by using the calculator and find the two values of t, which is negative 2 and 2. But here we only can have one t value, and it's quite obvious because this t equals to negative 2. T is time. time cannot be negative. That's why for this value, we are going to reject. So the value of t that we want is 2. So since we have the velocity equation already, I'm going to put this equation here. Okay? And for part B, we need to see when particle A stops instantaneously, find the distance of particle A from fixed point P. Okay, so meaning, just now we have found out that particle A stops when t equals to 2. So now, we need to see when t equals to 2, what is the distance of A from fixed point P. Okay, so now we need to go back here. Distance, does it relate to S, V, or A? So distance would be the distance from P to the location of A when it is t equals to 2. So see, I have mentioned the word location. So this we need to look at S. Okay, because S describes the location of the particle of any t value. Alright, so now we need to find the S when t equals to 2. But the issue is we don't have the S equation yet. We only have A and V. Okay, so we need to use back this relationship again. So if we want to find S, then we need to use V to integrate and get S. Okay, so means now we are going to integrate the velocity equation to find the S equation. Right, so here same thing as well, we are going to add 1 to the power and divide with the new power, which is 2 plus 1, which is 3. Okay, and since this is just a number, so we are going to add a t. And don't forget, here the integral there's no values, so we are going to add c. Okay, but again, this cannot be our final S equation. We need to figure out the value of c. Okay, so here, let's go back to this diagram again. Just now we have mentioned that at the start, the experiment starts when particle A stops at P. So what is the S when t equals to 0 in this case? The experiment starts when A is at P. So the distance of particle A to P is 0, right? Because it is actually on the starting point. So our distance or our S here is 0. Okay, so if we substitute t and s with 0 inside this equation, c will also be 0. So our S equation would be t cubed over 3 minus 4t. Okay, so now we have the S equation already, then we can substitute the value of t that we want inside here. Okay, and then you'll notice that the S value is negative 16 over 3. So what does this mean? Okay, this means that if let's say point P is here, basically when t equals to 2, it is already on the left side of point P. Okay, why do I know it's the left side? Because of the negative here. If S is negative, it's on the left side of the original point, which is P. Okay, and the distance between A and P when t equals to 2 would be the value only, 16 over 3. Okay, so when we write out the final answer, make sure you just remove the negative, because this negative is just describing where is the particle from the original point. Is it on the left side or the right side? But this negative doesn't really describe the distance, right? So we can just remove it and to retain the value here. So here I updated the information a bit. So now I am putting the S, V, and A equation for A, for particle A, and here particle B will be the velocity equation lah. Okay, so in part C here, we need to find out the time again if both particles meet each other. Right, so again, we are going to ask ourselves the same question. Is it S, V, or A? So let's imagine what happens if both particles meet each other. So it will be something like this, right? Let's say particle A is here, then particle B would be also at the same point. So here, we are looking at the location, right? If they have the same location, means both of them are meeting each other. So since I've mentioned the word location, so we are going to use S also. Okay, so since here it says they meet each other, meaning the value of S for particle A and particle B is the same. So if you want to find the time, why not we form an equation where SA is equal to SB? Alright, because their location is the same when they meet each other. Alright, so now we have the S equation for particle A, but we don't have the S equation for particle B. Okay, so again, if you want to find S by using the V equation, we are going to integrate V. Alright, so we are going to do the same thing also. So here, add 1 to the power and divide with the new power, which is 2 plus 1, which is 3. Okay, and then here the power is 1, and then we plus 1, and then we divide with the new power, which is 1 plus 1, which is 2. So here will be negative 4t squared over 2. And also here there is no values in the integral, so at the back we are going to add a c. Okay, and let's simplify this. So here can 4 divided by 2, so you get 2 here. Alright, so again, this cannot be our final equation because we need to find the value of c first. Okay, so here we need to learn a technique. So here we have two particles, right? And for two particles, if we want to make sure, if you want to find when does it meet each other, we need to set the same reference point for these two particles. Okay, so if we have the same reference point, then we can able to know when did they meet each other, right? Because imagine, right, if we have two different reference points, let's say P and Q, it will be very confusing. So for example, right, okay, let's say point P is here, point Q is here, and for particle A, it is like 4 meters away, right? So 4 meters away can be here. Then I say, oh, particle B is also 4 meters away, but it's from Q. So basically, particle B is here. So even though they have the same distance, but since their reference point is different, then you can see that they are actually not on the same place. Okay, so what we are going to do is we are going to ignore Q. We are going to use P as the reference point for both of the particles. Alright, so now if we ignore Q and we use P as a reference point, so let's find the S when T equals to 0. Right? So T equals to 0 meaning at the start of the experiment when A passed through P, when is B? Oh sorry, where is B? So B is actually 6 meters away from P, right? So here our S is 6. But is this 6 positive or negative? The answer is positive, right? Because B is located on the right side of point P, right side of the reference point. So this is a positive value. Okay, so here if we have two particles, make sure we use this technique. Use the same reference point or use the same starting point. Okay, so now let's use this information and substitute inside the equation here to find the value of C, right, which is 6. So this would be our S equation for particle B. Okay, so now we have the S equation for both particles already, so let's equate them together and then find out the value of T. Alright, so I'm going to move everything from the right side to the left side. And you see that all of these values are even numbers, so I can simplify them by divide 2 for all of the values here. And then you can see that this is a quadratic equation, so I can use factorization by using calculator to figure out the two values of t, which is t equals to 3 or t equals to -1. So again, here we only need to have one value of t, and here clearly we need to reject t equals to -1 because time cannot be negative. Okay, so our answer here will be t equals to 3. And for the last part, we need to find the range of time when both particles move to the left. Right, so here it says range of time, which means that in our final answer, there will be the inequalities. Alright, and here it says both particle moves to the left, so again S, V and A, which one should we use? So here it says moves, which means there is movement, so we need to use V for this case. Right, so what would be the value of V when it moves to the left? So just now we have mentioned that if the velocity is a negative value, then it moves to the left. Alright, so if you want to find the range of time, we need to make sure the velocity equations VA and VB is less than 0. Okay, so let's use these two inequalities to find out the range of time. Right, so I'm going to substitute the equation of velocity for A and B inside the inequality here. Okay, and then we are going to factorize one by one and to find out the values of t. So now we have two quadratic inequalities. So the first step to do this is we are going to factorize this by using the calculator to find the two values of t first. Okay, so you put this into a calculator, you will get these two values, so which is 2 and -2. And now to find the range of values of t from this inequality, we need to use a technique that we have learned in Form 4 Chapter 2, right? Which is using the graph method to figure out the range of t, okay? Which is this graph, right? So since it is less than 0, which means we are going to look at the region which is below the x-axis or the t-axis here. Okay, so our region here would be the one at the bottom where t is between -2 and 2. So same goes for the second inequality also. We are going to factorize. So here we can just take out the t from these two values. So here we'll be left with t -4. So the values of t here is 0 and 4. Okay, and using the same technique, which is the graph method, and here also less than 0, so the range is also below the x-axis or the t-axis. So our answer here is between 0 to 4. Okay, so now we have these two range, we need to combine them. So the best way to combine them is through the number line. Since all of these inequalities are not equal to, right, there's no the equal to sign, which is this equal sign. The extra line at the bottom, since it don't have, means that all these value of t cannot have -2, 2, 0 and 4. Alright, so for the number line, I'm going to draw a hollow dot, okay, which means that here I cannot include -2. Alright, so for the first inequality, it would be from -2 to 2. And the second inequality, it would be 0 to 4. And then I find the common point. Oops, sorry, let me redraw this again. Alright, so now we need to find the common area, which is here. So as you can see, it starts from 0 until 2. So our answer here would be t is between 0 to 2. Question 13, coming from the index number chapter. So in this situation, we have 4 materials A, B, C, D, and it's used to make this furniture. Alright, so here we have a table and it is describing the price index of these 4 materials A, B, C, D from 2020 to 2025. Okay, so you can see that the price index here is in percentage format. Alright, and then on the right side we have this graph, so it is explaining the percentage of each of the materials to make the furniture. Alright, so here it says that the production cost of this furniture is this value in 2025. So in part A1, it says that if the price of material C is in 2020 is 57.6, what is the price in 2025? Okay, so let's recall back the formulas that is in this chapter, which only has 2. So one is called the price index and the other one is called the composite index. But here, let us focus on the price index first. So price index is basically a value that describes the change of the price. So if you want to figure out the change of the price, we need to compare prices from 2 different years. Okay, that's why you will see there's P1 and P0 here. Okay, 2 prices from different years, and then to see what is the change of the price, which would be the value of I or the price index. But in this chapter, there is also another very important thing to take note, which is in this chapter, there are 2 kinds of years. Alright, so one is called the specific year, and the other is called the base year. Okay, so let's understand what is specific and what is base first. So let me give you a very simple example. Okay, let's say me. I am the specific person and my height is, for example, 168 cm. Okay, but I want to know whether my height is higher or shorter. But of course, if I want to compare, I need to compare with something, right? So that would be my base, my reference. Okay, so let's say this person is 170 cm. So I am shorter, right? According to my base or my reference. Okay, so I am the specific and the other person is the base. Okay, so here, jumping into here, the specific year would be the current year. Base year would be the year that I have selected to compare with. So usually for specific year and the base year, the larger year usually would be the specific year, the smaller year would be the base year. So for example here, if you see, it says changes from 2020 to 2025. Right? And then you see the changes here. So meaning to say, 2025 is our specific year, our current year, and we are comparing with 2020, which is our base, which is our reference. Okay, so the prices from 2025 will be put on top, and then the prices in 2020 will put at the bottom. Okay, so specific year will belong to the top, base year will belong to the bottom. Alright, so coming back to this question, we need to find the price of material C in 2025. So let's use this formula. Alright, so for the I, I'll be writing something like this. So the index here would be 2025, which is our specific year, based on year 2020. Alright, which is our base year. And then here I put a C, so it's indicating material C. Okay, so this is for the I part. Then for the P1 and P0 here, so just now we have mentioned that for specific year is 2025. So here I will be putting P 2025 and then I'll put C on top because it's material C. Okay, same goes to the bottom. Here would be the year 2020. And then I multiply 100. Okay, so now what we need to find is this one. Okay, and let's say we put it as X first. So we need to figure out this value, which is the index, and the price of the material C in 2020. Okay, so the index or the price index, we can look at the table here, right? Because here are the price indexes, sorry, indices. Okay, so if we see the material C is increased 20%, right? So this is in the percentage format. How do we change to the number format? Okay, so let me bring down this table. Right, so basically, if you see increase M percentage, then if you want to change to the price index, it's just 100 plus the M value, the percentage value, right? So here, very simple, it's 100 plus 20. Okay, so if we see the other materials, for example, this one decreased 10%. Okay, so this one we need to do the other way. So if you see here, decrease M percentage, then here you need to 100 minus, okay, not plus here, minus M. So here will be 100 minus 10, which is 90. Okay, so the other two values, they are increasing, so it's just 100 plus the percentage value. So here will be 160, here will be 140. Okay, and another thing to take note is, if it's no changes, then it will remain 100. Alright? Okay, so now we have already found the price index for material C, which is 120. Alright, so for the price in 2025, I'm going to put X. And for the price in 2020, it is given in the question here, 57.6 ringgit. And we are going to pull down the 100 here. Okay, so once we rearrange the equation here and there, then we can find out the price in 2025, which is 69.12. And for part 2, here it says the price index for B, right? So we are focusing on material B now. It's in the year 2027 based on 2025 is 136. Okay, so if you see here, 2027, we have another new kind of year. Alright, just now it was 2020 and 2025, so now we have 2027. Okay, so let us write this sentence into an equation using the price index. So what I'm going to do here is, for the price index here, 2027 based on 2025 for material B is 136. Okay, and the next information is the price of the same material B in the year 2027 is 17 ringgit more than 2020. Okay, so let me write out this equation by putting the price of 2027 and 2020 first. So the price in 2027 is higher than 2020, right? So for 2027, it is higher. So if you are stuck on, this 17, where should I put it? Should I put it on the left side or right side? Okay, so you can treat this as you are balancing the equation. So since here is higher and here is lower, so I'm going to add the value on the right side. So here lower, I add a value to balance both sides of the equation. Okay, so this is how I do it when I'm a bit stuck, how to add the values. Should be on the left, should be on the right. So the aim here is to balance the equation. Okay, so now we need to find out the price of material B in 2027, which is this one. Okay, so since this is the value that we need to find, and in the same equation there is 2020 here, so why not we use this price index but using 2027 and 2020. Okay, so the formula would be something like this. The price index of 2027 based on 2020 for material B is equal to the price in 2017 over price in 2020 times 100. Okay, so if you notice, we don't really know the values for each of these things. Okay, each of these things we don't know. Okay, so let's focus on the index here. Right, so why I say focus on the index here? Because just now in the question, they also gave us another index. It's just that it is different years, right? This one is 27/25. This one is 27/20. And then if you notice, there is also another index for material B in this table, right? So this one is also a different price index. This one is the index of 2025 based on 2020 for material B. This one is 160. Okay, so you see, now we have 3 different kinds of index for the same material. So how should we use these 2 index to find out the value of this index? Okay, so let me introduce this 3-step method to solve this kind of question. Okay, use under indices to find the other index. Okay, so this method is legit and it's displayed in the textbook also. It's in page 275 for the English and also the Malay version. Okay, y'all can check it out. And just to let you know, the working is not in the space where they always do the working. It's in a box called alternative method, or in BM is Kedah alternative, and you will see the steps there. So for the steps, it's actually just 3 steps only. Okay, so the first one is to find. We need to find the other 2 index to find the other index, which we have already done, right? Which is one index is here and the other index is here, right? So here we need to find the 2 index. Okay, the second thing is we need to arrange. So arrange meaning we need to look at the years which are involved, right? So you see 2025, 2020 and 2027. So what I'm going to do is I am going to arrange them in the descending order, largest to smallest. Alright, so here would be 2027, 2025 and then 2020. Okay, so this is the second step, to arrange the years in the descending order. Right, the third step is to use this formula. So the formula I'm referring to is this one. Okay, it's just that for the p's here, we all change to I. Right, all change to I. So everything here would be the price index. There will be no prices, there will only be price index. Okay, so now what kind of, so maybe asking what kind of years should I put for all of these indexes? Okay, so we need to look at the arrangement here. So for the first index, I am going to put the first 2 latest years, which is 2027 and 2025. And since we know that for the Pacific year, it's the larger year, so we are going to put 27 at the front, 25 at the back. Okay, so we are going to choose the 2 latest years, going to put inside the first index. Okay, then for the second and the third index here, for the first year, I am going to use the years based on here. So 2027 will be put on top, 2025 will put at the bottom. Okay, and then we have left with one more year, right, which is 2020. So for the 2 index here, I am going to put the same year for both index. Right? So both of them will be based on the year 2020. Okay, so this will be the third step. How do we substitute the years inside the formula here? Right, so recall again, for the 2 latest years, I'm going to put at the first index. Then the 2027 and 2025, I'm going to put 2027 on top, 2025 at the bottom. And then we are going to put the last year at the back of these 2 index. Okay, so now we have this formula already, then it's very straightforward. Because now we can just substitute the values of the index into this formula. So for 27/35, it will be 136. This one would be the index that we are trying to find, so we're going to remain it as the same. For the index below, it would be changed to 160. Okay, and don't forget the multiply 100 here. So once we rearrange the equation here and there, then we can find out the price index of 2027/2020 for material B is 217.6. Okay, so now we can move this price index into this formula here. Okay, so how about the prices here? Okay, so since we are finding this one, right, the price of 2027, so let us use this as X. Okay, so this would become X. And then what I'm going to do here is this price 2020, I'm going to change it where it has X. Okay, so means if I want to find the price of 2020, basically I move the 17 to the other side. So here would be X minus 17. So price 2020 would be X minus 17. Okay, why I do this is because I want to find the price of 2027, right? So for the price 2020, I'm going to change it based on price 2027, which is X. Okay, which is why here I move the 17 to the other side to find the expression of price 2020, which is X minus 17. Okay, and then don't forget the 100 here. So for the X negative 17, I'm going to move it to the left side first. And also for the 100, I'm going to move it to the left side and divide with this value. So here will be 2 places to the back. So here will be 2.176. Okay, and this value will multiply inside the bracket here. And then I move the X to the left side and this value to the other side. Okay, so X move here, this value move there, and then we have this equation, and then we move 1.176 to the other side, and then we can get the value of X, the price of the material B in 2027, which is 31.46. And for the next part, here it says we need to find out the production cost in the year 2020. And if you realize, it doesn't really say it is for which material, which means this production cost is the cost of the entire furniture, which means include all 4 materials. Okay, and also in the question here, it also gave us the production cost of the entire furniture. Alright, the entire furniture in 2025. So since we have the price of one of the years, why not we also use the same way, which is using the price index to find out the production cost in 2020, right? Because production cost is also a price, right? So here for the I, I'm going to write something like this. So I would be 2025 based on 2020. So here we have an issue because we already know the price of 2025 and we want to find out this, but we don't know the price index of the entire furniture. But what we do have is the price index for each of the individual materials here. Okay, so what we can do is we can combine the price index for all these 4 materials and then to form this combined price index for the entire furniture, because again this furniture is made up of these 4 materials. So to do so, we can actually use this composite index formula. So another word for composite is combine. Alright, so we're going to combine these price index using this formula. And if you notice that this notation for composite index, there's a horizontal line on top. Okay, so if you see at the bottom, you can see this horizontal line here. So just now I didn't mention, okay, because this I is actually the combined index from the individual index here. Okay, so that's why there's a horizontal line at the top here lah. Okay, so how do we find the composite index? So let's go through the numerator. So numerator here is I and W. So means we are going to multiply the I and the W, but what are they? So I is actually the price index. W here is the weightage, meaning the importance of that thing. Okay, so let's say we start off with material A, right? So the I here, or the price index, is 90. Okay, but how about the weightage, the importance? So to figure out the importance, actually we can look at this graph, right? And then you can see that A is the longest, meaning it has the highest importance, right? So we need to find out how important it is by looking at the percentage value here. So for material A, it is 50%. And this would be our weightage. So here we need to multiply the two values. So here to start off would be 90 multiplied with 50. Okay, and then the symbol here, this is called the sigma also, and it tells us to add up all the IWs from all these four materials. Okay, so let's move on to material B. So the price index of the I is 160, but the W here, they didn't give us, so we have to calculate it out. So we have to calculate the percentage of the other materials first. So C and D is 10. So B, if I want to calculate B, it would be the percentage of all these four materials, which is 100%, minus 50, minus 10, minus 10, which would be 30. Alright, so we need to multiply the I and the W, so it's 160 times 30, and I'm going to add them up together. Okay, same goes to material C and material D with the same method. Okay, and then for the denominator, so here means that we need to add up all of the weightage. So here will be 50 plus 30 plus 10 plus 10. Okay, so once you summarize or simplify numerator and denominator, it will be something like this, and then you divide these two values, you will see that the composite index is 119. Okay, so now we have this value already. Okay, so using this equation, let's substitute the values that we have. So here will be 119, price of 2025, we are going to use this value, 41650. And for P 2020, the price in 2020, I'm going to put X. Okay, and then rearrange this equation here and there, and then we can find out the value of X already, which is 35,000. And for the last part here, it says the production cost is expected to increase by 60% from 2020 to 2027, and then we need to state and calculate the percentage change in the production cost from 2025 to 2027. So if you see the entire question, right, it only mentions production cost. It doesn't really specify it's which material, so means that this production cost is for the entire furniture. Alright, and then from the first sentence here, it says increase by 60%, which means this production cost can be written into a price index, or because this is the production cost of the entire furniture, this is a composite index. Okay, so let's change this percentage to a composite index. So let me take down this table again. Okay, so since it is increasing, so we're going to add 100 with the percentage value, so it's 160. So let me write here. Okay, and I'm going to write out the symbol of the composite index. And for the years, how do we write the years? So here it says from 2020 to 2027. So 2027 is our year, and since it says from 2020, so 2020 is our base year. Okay, so 2020 at the back. Alright, so this would be the composite index for the first sentence. And here we actually want to find, here, percentage change. So again, percentage change, we can also change it to an index, a composite index, because here it says production cost. So this one is, we need to figure out the composite index of 2027 based on 2025. Okay, why 2025 is at the back? Because here it says from 2025. Alright, and we need to figure out this index. Okay, so actually we can use back the method that we can use other indices to find another index. Right? So the first step here is to find the other two composite index. So we have found one already, which is in this sentence, and just now in part B, we also found another composite index, right? Which is this one. 2025 based on 2020 is 119. Okay, so now we have our two composite index already. Okay, so we go to the second step. So again, second step is to arrange the years by descending order. So it will be 2027, 2025, 2020, same as the question before. right? And third is using the formula. The price index formula is just as everything, we change to the index. Okay, so here we are using composite index, right? So here would be all with composite indices. Okay, so now we can arrange the years according to the technique just now. So we're going to put the two latest year at the first index, so 2027 based on 2025, and then the largest year 2027 I'm going to put it on top and 2025 put it at the bottom, and then for 2020 I'm going to put at the back of these two indices. Okay, so now we are trying to find this index. Okay, this index, so we are going to substitute the values of these two indices inside this formula and to find out the value of this composite index. Okay, so this is 160, this is 119, and we calculate it's 134.45. Okay, so this is the index, so don't forget to change it to the percentage format. Okay, so from here, how do we change to the percentage format? So basically just now, we are adding 100, right? From percentage to index, we add 100. So now if you want to change back, it will be minus 100. So this value would become 34.45%. But we also need to explain the meaning of this percentage, right? So here, let me use some of the words here. So we can say that change in the production cost from 2025 to 2027 is, okay, so this index is more than 100, right? And just now we've mentioned that if the percentage is increasing, we need to add 100. So since this is more than 100, which means the change in the production cost increases by 34.45%. Alright, so this would be our explanation. For the next question coming from solution of triangles, and in part A, we are given a piece of land, and here it has a different purpose for each piece of land. So here for the triangle ABC, it is for growing mustard greens. For triangle ACD, it is for growing cabbages. And for the pond DEF, which is this triangle, it is for the water supply. Alright, and here it also says that AD and DF are perpendicular, right? Which means that this line and this line are perpendicular. Okay, and here there are a few information here. So let me write the lengths of these three lines onto this diagram. Okay, 80, 90, and 100 here. So 100 here is just from C to E, yeah? It's not C to D, it's C to E. Okay, so let me label it here. And then we have the sine angle CAD, which is this one, and it has the value. So I'm going to put a label here lah, just to indicate that we have the value for this angle. Right, and EF is 6 meters. So EF is this line, but since this line and this line is the same, so both of them is 6. Sorry, both of them are 6. Okay, so for part 1, we need to figure out the area of mustard greens, which is triangle ABC. Alright, so if you notice this triangle, there are no angles. Alright, and in this chapter, if you recall, there are two ways to find out the areas, which is this one. Okay, so this one involves two sides and the included angle. So included angle is the angle between these two sides, and the Heron's formula, we need to use all three sides of triangle. So since we don't have the angle, so we don't need to use the first way. We can use the second way, which is the Heron's formula, to find out the area. Okay, and yes, this is actually a summary table for all of the formulas inside this chapter. So you can screenshot this table, and then we will explain the formulas as we go along. Alright. Okay, so let us go to here. So we need to use the Heron's formula to find out the area of this triangle. But the issue is we don't know the length of this line AC. Alright, so we need the other triangle help to find out the length here. Right, so let me pull out the formulas that is given in the formula sheet for this chapter, okay, from formula 38 to formula 40. So if you want to find the sides, usually we need to use these two formulas. So this is the sine rule, this is the cosine rule, but usually to choose either sine rule or cosine rule, usually I will look at whether can use sine rule or not, because it's much more straightforward, right? So here, let us find a pair first. Because sine rule, we need to have a pair, which means the length and its angle. So here, actually, we have the length of this line and its angle. We also have the value, right? Because here it says sine CAD is equals to 4 over 7. Right? So technically, this is a pair. Okay, so now we have found our pair already, and now since we are focusing on finding the length of AC, we need to have its angle also, which is this one. Okay, so the angle that we are focusing on is this part only, not the entire part, but this part only. Okay, this part only. So to find the angle of this part, we need to find the angle here first, right? The angle here. So if you notice, these two lengths are the same, which means that these two angles would be also the same, right? So if you want to just find one side of the angle, right? So we can look at the total angle in the triangle, which is 180, right? 180, and then I minus out this part, because this part is perpendicular, which means the angle is 90 degrees. And since there are 2, so I'm going to divide by 2. And then once you calculate this, the angle that you get is 45. So since here is 45 and the entire angle here is 90, so 90 minus 45, here will be 45 as well. Okay, so let me write off this. Okay, so we have found our angle, which is 45 degrees. So now we have all the information that we need to find out the length of line AC using the sine rule, and let's substitute the values inside the sine rule here. Okay, so we're going to find the length AC. So at the bottom, I'm going to put its angle. So here will be sine 45, and then on the right side, I'm going to put the length of the pair. So again, here C to E is 100. How about E to D? So since this is a right angle triangle, so I'm going to use the Pythagoras theorem. So means for these two lengths, I'm going to square them. Alright, add them up together and then square root it, right? According to the Pythagoras theorem. So 100 plus this value. And then at the bottom, I'm going to put the angle of it, right? Which is the sine CAD. Sine of this angle, right? Which we already have the value, which is 4 over 7. So later on, we just substitute sine CAD with 4 over 7. And then we move this sine 45 to the other side. Then we can figure out the length of AC already, which is 134.24 meters. So now we have the lengths of all the sides of this triangle already. So we can use the Heron's formula. So first thing first, we need to figure out the value of S. So this one very simple. It's just adding up all the lengths of the sides of the triangle. Alright, and then divide by 2 to get the value of S. And then we are going to substitute the value of S inside the formula here. Alright, so we are going to multiply 152.12, and then we are going to multiply the S value with the difference of each of the length of the lines here. Okay, so meaning 152 minus 90, 152 minus 80, and 152 minus 134.24. Okay, so once you put this into your calculator, then you can figure out the area, which is 3490.76. And don't forget the unit, which is very important. Here, as you can see, it uses meter, so we need to put meter square. For part 2, we need to sketch another triangle which has a different shape from the original triangle ACD, okay, which is this one. And here we need to sketch a triangle ACD prime with the conditions here. So here it says CD equals to CD prime and angle CAD equals to angle CAD prime. So here the symbol is called prime, and prime here means that the value of D would be another new point. Okay, it's D but a new one. Alright, which is actually a hint when we are sketching the triangle. Okay, so let me introduce y'all the 3-step method to draw a new triangle. Right, so the first step is to find the unfixed side from this triangle ACD. Okay, unfixed side meaning you can adjust the length of the side. So since D is the only thing that has the prime, which means this D can be adjusted because we need to find a new D, right? So it can be the D I move from here to here, or I can move to here, the line AD. So it can be I move between CD or AD. Okay, so if we look at the first condition, right? Okay, so let's see if I move these 2 points, can this condition be satisfied? So if you see the first point here, CD equals to CD, the length cannot be different. But if you see here, line CD is this length and CD prime is only part of line CD. No matter how I move D prime, sorry. No matter how I move D prime. So if I move here, these two lengths will never be the same, right? CD prime is here, CD is the entire line. So no matter how I move D prime, it will always be different. And I cannot put D prime here also, right? Because this D prime and D must be different. Okay, so means that this D prime cannot be on this line already. So it should be on this line AD, which means that this line is the unfixed side. Okay, so this is the first step to identify the unfixed side. The second step is to identify the unfixed angle from the side. So meaning it's either angle A or angle D. Okay, so if you look at the second condition, the angle A must be the same, right? Which means this angle A is fixed already. So the only unfixed angle here is D, right? So this would be our unfixed angle. Right? So once we have the unfixed angle, then we go to the third step, which is from this unfixed angle, is it an obtuse or an acute angle? So recall back, for acute it is less than 90 degrees. For obtuse is between 90 to 180 degrees. Okay, so since in part 1 just now, we have found out that the angle D is 45, which is less than 90. So this is an acute angle. Okay, so if we see that this angle is an acute angle, which means we need to draw the new triangle on the inside of this original triangle. Alright, because it is acute, we are going to draw the new triangle inside the original triangle. Okay, so what do we mean by inside is, for the point D here, I'm going to move to the inside. Alright, from here to here. Okay, so this would be our new triangle. But there are a few things to take note. So first thing is, for the point D, make sure you put prime. because this is a new point of D, and also make sure that the original CD has the same length of your new CD also. Don't make it too, I would say, if you compare the diagram here and you're working here, the difference is too big, then most likely your drawing will be rejected. Okay, so make sure it is almost the same length from the original CD. Okay, so make sure two things. One, put prime. Second thing is make sure your line CD is the same as the original CD. Alright? For the third part, here it says this owner wants to build a cemented path at point C in the cabbage growing area, which we know is triangle ACD, right? And then C would be here. So the path starts from point C, and here it says we need to find the distance of this path in the minimum cost. So what does minimum cost mean? Meaning we are going to use the lowest cost available to form this cemented path, or meaning we need to figure out the shortest path of this cemented path, right? Because the shorter the path, the lower the cost. So in this triangle, starting from point C, what would be the shortest path? So this is what we learned in question 11, right? So let's say we are at point C and we need to find a way to reach line AD or the other side of the road in the most fastest way. What would be the way? Which is to walk straight, right? Walk straight towards G. Okay, this would be our shortest distance to the other side of the road. And what we learned in question 11 also is the path that we went and the line that we reached. These two lines are perpendicular to each other. Okay, perpendicular to each other. So this red color line would be our shortest path. And now we need to find the distance of this shortest path. So if you see, actually this shortest path is part of this right angle triangle. And then we have an angle at point D. So this means we can use the trigonometry way, which is the opposite, adjacent, and the hypotenuse way, to figure out the distance of this line. Okay, so if we use this angle as the reference, so this line is actually the opposite line, and line CD, okay, line CD, this is the hypotenuse. So why I choose this line is because we already found the length of this line already. Okay, so O divided by H is using sine, right? So we can form an equation using the sine function. So here will be sine 45 equals to O, which is our line CG, divided by the length of this line CD. So it will be 100 plus these two 6 values using the Pythagoras theorem. So 6 square plus 6 square, and then we square root. Okay, and then once we rearrange this equation here and there, and then we can find out the length of the shortest path, which is 76.71 meters. Okay, so for this question, it surprised me because for this part 3, it actually has 4 marks. But as you can see here, we only have 2 lines. And I also noticed the workings here and the workings in the answer scheme is totally different, which I'm not really sure why they use the longer way. Okay, so for this video, I will be explaining why the answer scheme also use the longer way. Okay, so this would be the second way to solve this question. Right, but of course, I will prefer this way because it's short and much more straightforward. So let's use another way according to the answer scheme's working. Okay, so again, we are trying to find the length of line CG here. Okay, so how do we do that? So actually, if you notice, this line CG is actually the height of the triangle, right? The triangle ACD, right? So meaning we can use the formula of area of triangle which has the height inside, which is what we have learned, 1 over 2 times the base times the height. So the base is this line AD, alright, line AD, and the height is what we need to find, which is line CG. Okay, but if you want to use this formula to find out H or line CG, we need to have the area of triangle and also the length of line AD. But the issue is we don't know these two things. Alright, so we need to find other ways to figure out how do we find the area of triangle and also the line AD. Alright, so if we start off with area of triangle, actually we have another formula that helps us calculate this. Right? So if we go to the formula sheet, in formula 40, you will see that area of triangle is also 1 over 2 AB sine C. So what is A, B, and C here? So A and B are actually the sides of the triangle, right? Two sides of the triangle. Let's say it's here and here, right? And then C is the angle between those two sides, right? Which is somewhere here, right? The angle between A and B. So if we apply this to here to find the area of triangle, so in this triangle, we have one angle here, which is 45 degrees. Okay, so this one can be our C. So if we want to find the area of triangle, we need to figure out the length of the sides here, CD and also AD, right? So CD, we have it, right? 100 and then plus this part here by using the Pythagoras theorem. But again, we don't have the length of line AD. Okay, so meaning if you want to use this formula, it will be 1 over 2 times A times B times sine C. So A, let's say it is CD, B is AD, and sine C, this angle. So let me put D because point D has the angle. Alright, so we have this and we have this, but we don't know AD. Same goes to the situation that we have here also, right? We don't know AD inside this area of triangle formula. Alright, so in order to find area of triangle and AD, we need to know what is the length of AD. Okay, so this is our focus now. We need to find the length of AD. So to find the length, usually we can use these two formulas, right? 38 and 39. So this one is the sine rule, this one is the cosine rule. But usually I would prefer to use the sine rule because it's much more easier. Right? But again, depends on situation lah. So let's see if we can use a sine rule inside this situation. So for sine rule, we need to have a pair. A pair meaning an angle and the length of the side. So in part A1, we already found that pair, right? Which is angle A and line CD. Okay? So now, since we are trying to find AD, we need to find out the pair's angle, which is angle C. This one. Alright, so how should we find this? Okay, so if you look at here, we have the angle here, and here I already drawn out this angle because remember, here we have the value of this angle, but it is in sine. Sine CAD equals to 4 over 7. So if we want to find out the angle, very simple, we just move the sine to the other side. Okay, so the angle here would be arc sine. Okay, so this is called arc sine, ARCSIN. It's not sine power -1, right? Arc sine 4 over 7 to find the value of angle A. Okay, so since we have the angle of these 2 points already, then we can use 180, which is the total angle in this triangle, minus these 2 angles. Alright, so it would be something like this. 180 minus 45 minus this value, it will be 100.15. Right? So now we have the angle of the pair for this line AD already. Then let's use the sine rule. Alright, so I'm going to put AD on the top, and below I'm going to put its angle pair, which is 100.15. And for the right side, I'm going to put the information of this pair. Alright, so the length will be put on top, which is 100 plus this part here, which is using the Pythagoras theorem, 6 squared plus 6 squared, and then square root. And then we are going to divide with the sine of the angle, right? Sine CAD, which is also 4 over 7. Okay, so I'm just going to put 4 over 7 at the bottom, right? Same as part A1. Alright, and then I'm going to move this to the other side, and then you can find the length of AD, which is 186.88 meters. Okay, so let's go back to our working here. Right, so now we have already found the length of AD already, which means we can find the area of triangle. Alright, so we are going to use this formula to find out the area of triangle. Okay, so let us go to here. Alright, and then we are going to use this formula. So 1 over 2 times A. A is this line. Okay, line CD, which we already found here, 100 plus square root 6 squared plus 6 squared. And then AD, which is this value, 186.88. And then we are going to multiply with sine C, which is also sine D, which is sine 45 degrees. Okay, and once we put this into the calculator, you can get the area of triangle is 7167.85 meters square. Right, so now we have the area of triangle already. Okay, and since we have AD and also area of triangle, then we can use this formula to help us find H. Okay, so let us put the formula here. So 1 over 2 times the base, which is 186.88, and then the height, which is also CG. And then I'm going to substitute the area of triangle here, which is 7167.85. Okay, and then we rearrange the equation here and there, and then you can find the value of CG already, which is 76.71 meters, which is the same answer that we have gotten in our first way of doing it. Okay, so because in questions, we don't really know how are the marks being allocated for part 1, part 2, and part 3. And since this question didn't really say you cannot use trigonometry way, if that's the case, then I would prefer students to use the first way. But if let's say in this question, it says that you cannot use trigonometry. Okay, if that's the case, then no choice, we have to go through these steps. Okay, so the way to solve this question, I would say, is to have this kind of framework first, of this kind of thinking first. Okay, so how did I come up with this one is, okay, for this line is the shortest path, right? And if you see this line, is the height. Alright, so if I want to find the height, which formula does it involve the height? Which is the area of triangle formula, right? That's why I came up with this one first. Okay, then I go through the things in the formula. Which one do we have? But in this case, we don't have anything, right? The area of triangle and the B we need to find ourselves. Okay, so for the area of triangle, I go deeper again, right? So the 1 over 2 AB sine C. Then I see for these values, do I have it or not? Which is, just now we have found out that sine CD and angle D we have, but it's just that AD we don't have. Okay, so now if you break down like this, you're able to see which are the things that we need to find. And then once we found out the thing, which is the line AD, then actually we can find the area of triangle, and then we can put it here, and then the line AD, I can put it here, and then we can find the H value, right? So we have found the area of triangle, and then we have found the line AD, then we can find the line CG, which is this value. And for part B, here we have this triangle ABC, and it tells us to derive or prove this formula, which is the sine rule formula, which is also one of the questions in the formula sheet. So this is actually a very similar question in the same year, same state paper, but it's in paper 1 and it's in question 6. So if you see part A, it tells us to prove one of the formulas in the formula sheet also. Okay, and if you look at my video there is 4 steps of solving it. But here, since it is a similar question, I'm going to use the same first step only, right? Which is to recall back how does the sine, cos, and tan come from. So these things are actually coming from the right angle triangle, right? So in this triangle here, ABC, I'm going to split this triangle to have right angle triangles, which is something like this. Right, so now you can see there are 2 triangles. Triangle AB. Okay, let me put a value here. Okay, so let's say it's D. So triangle ABD and also triangle ADC. Okay, ADC. So now you have 2 triangles. Okay, so if you see these 2 triangles, they are sharing the same line. And let me put the length of this line. Okay, so let's say it's T. So since in this formula that we are trying to prove, you can see there are signs inside, so why not we form equations according to sign? Okay, but first things first, we need to have an angle from these 2 right angle triangles first, right? Right, so let's say I select angle B and also angle C. Okay, why I choose angle B and angle C? Because here, yes, you see sine B and sine C. The angles are B and C. That's why I'm going to use B and C here. Right, so let's focus on the first diagram. Right, if we want to find out sine B, right? Remember, sine is opposite divided by hypotenuse. So what is opposite here? Opposite is T, right? And then below here is the hypotenuse, which is C. Okay, and if I rearrange this equation to have T on the left side, it is T equals to C sine B. Okay, so this is for the first triangle. Then for the second triangle, I'm also going to do the same thing. I'm going to find out the value of sine C. So again, opposite, which is T also, divided by the hypotenuse, which is B. Okay, and then I'm doing the same thing in the first equation also, T to move to the left side, everything else to the right side. So now if you see the same value, but it has 2 kinds of expressions. So these 2 are actually T. So why not we equal them together to form an equation, because both of them are T. Okay, so now what I would do is, for B's, I'm going to move all of them to the right side, and then for all the C's, I'm going to move them to the left side. So why I do this is because, you see, sine C move to the left side, and then it will be over sine C. So this part is actually this part. And if you see on the right side, B divided by sine big B, capital B, which is also the same thing from the left side. Okay, so actually we are almost there already. It's just that the C's are at the left side, B are at the right side. So we're gonna switch their places. Okay, B on the left side, C on the right side. And then you can see we have proved the formula. Okay, so again, to recall back the steps, so the first step is to recall back how the sine, cos, and tan come from, which is through right angle triangles. Alright, and then what we need to do is we draw out the right angle triangles from this triangle. Okay, and then we find the values according to the trigo values here. So here, since it says sine B and sine C, we are going to find sine B and sine C in this triangle also. Okay, so once we have these two things, and then you can see both of them are equal to t. And then the last step is to combine these two things together and then place the things here and there, and then to find the final form of the equation, which is what we are trying to prove, right? Which is this one. Last question in this paper coming from linear programming. So let's skip the paragraph here first and let's go to part A. Here it says we need to write out the 3 linear inequalities that satisfy the condition above. Right, so let me share the tips to write out the inequalities. So in the paragraph later, which is here, if you see they mention total of something, or it compares the items, then we can form the inequality from those sentences, right? So example of comparison is, let's say x is more than y by blah 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 blah. So that is actually a comparison. So if you see those kind of sentences, then we can form inequalities from there. Okay, but first things first, let us understand what is x and what is y first. Okay, so here it says x is the chicken set and y is the meat set. Okay, meat means beef lah. So let's go to the first sentence of this paragraph. So here it says this owner sells 2 types of Rama rice sets, which we already know, which are the chicken sets, which is x, and meat sets, which is y. And then it says that the cost of preparing the chicken set is 3 ringgit and meat set is 4 ringgit. So here we don't really see it mentions total or comparing the chicken set and the meat set. So we are going to ignore it first and let's go to the next sentence. Alright, so here it says the owner has a capital of 1200 per day. So what is capital here? Capital here means the budget, or meaning the total cost of the rice sets here. Okay, so since it mentions the total, so we can form an equation or an inequality from the cost here. Okay, so since here is mentioned the total cost, so let's find out the total cost if we use the x and the y here. Right, so here one set of chicken set is 3 ringgit. So if you want to find out the cost if we do x sets, then it will be 3 times x, right? Same goes to the meat set as well. If one meat set is 4 ringgit, then y sets would be 4 times y. So we're gonna add up these two things together, 3x plus 4y, right? 3x plus 4y. So can this value that we have exceed this value? No, right? Because this is the budget, the total cost. So we cannot exceed this value. But we can make it to be the same as this value, 1200, or below. Right? The same or below, which means that the inequality here, it would be lesser than and equal to 0. Now, going to the next sentence, here it says that the number of lunch sets sold each day is more than 200 sets. Okay, number of lunch sets sold. So this is technically another word of total also. The total number of lunch sets sold for the day. Okay, so the total lunch sets here would be x plus y, right? X plus y. And then here it says more than. Okay, more than. More than means the symbol would be just this. Okay, so in our next inequality, it is x plus y, which is the total number of lunch sets, and then will be more than 200. Okay, so for this part, please take note, yeah, the inequality symbol there does not have an equal sign below. This one is just more than. right? Because in the sentence here, it says more than. That's why there's no equal sign here, right? So sometimes these cases might happen, right? So what are the differences between inequalities that have equal sign and don't have equal sign? So we can go to part B and then we'll explain that, okay? But let's find the third inequality, or the third, third inequality. So let's go to the next sentence. So here it says the number of meats sold is not more than 3 times of the number of chicken sets. Okay, so again, meat sets, we know that it is Y, right? We know that chicken sets is X. So what does not more than 3 times mean? Okay, not more than. Not more than means, okay, so we have 3 types, right? One is less than, one is equal, and one is more than. So if it's not more than, means it is less than and equal to, right? So our inequality here will be less than and equal to. And then here it says 3 times the number of chicken sets. So the chicken sets here, I'm going to multiply 3. So this is our third inequality. Y lesser than or equal to 3x. Okay, so this would be our part A. So now we have these 3 inequalities and we can go to part B. So using a scale of 2 cm to 50 units for both axes, we need to construct and shape a region R which satisfy all of the conditions here. Okay, so now let's go to our graph and to draw the shaded region R. So to form and shape the region R, we need to go through these 4 steps. Alright, so the first step is the axis, second step is the lines, third step is above or below, fourth step is the region. Right, so let's go to the first step, the axis. So axis here meaning these two x and y axis lah. Right, so let's make sure the label is correct. So here the x-axis label is x, the y-axis label is y. And then we look at the scale, right? So here it says 2 cm to 50 units for both axes. So again, 2 cm is the big box here, right? This is 2 cm. So for every 2 cm, we need to have 50 units for the x-axis and for the y-axis also. Alright, and then if you want to find the value of the next number, very simple, we just keep on adding 50 until the end of the axis. Right, same goes for the y-axis also. Okay, so now we have completed our axis, and let's go to the second part, which is to draw the lines. So how do we draw out the lines according to these inequalities? Well, we need to have 2 points for each inequality, right? 2 points. So the fastest way to do that is I am going to find out the x-intercept and the y-intercept of all of these lines, right? Because x-intercept is a point, y-intercept is a point. I have 2 points, and then I can able to draw the lines from those 2 points for each inequality here. Okay, so to find out the intercepts, okay, here we need to do something, which is let us assume that all these inequalities are equal temporarily. Okay, we assume that they are equal first to find the x and the y-intercept. Alright, so okay, so let us find out the x-intercept. So x-intercept is where y equals to 0, and the y-intercept is where x equals to 0. Okay, so let's find out one by one. So if x-intercept, y equals to 0, so if I substitute into the first inequality here, this part will disappear, so 3 will move to the other side, so the x-intercept is 400. Right? And then for y-intercept, which x equals to 0, so this part will disappear, and if you move 4 to the other side, then it's y equals to 300. Okay, so we have found the 2 points for the first inequality. And now let's go to the second inequality. So y equals to 0, this will disappear, and x equals to 200. Right? 200. And for y-intercept, x equals to 0, this part disappears, so y equals to 200 also. And for the third inequality, y equals to 0, so if I move 3 to the other side, it's also 0, so x equals to 0. Okay, and for y-intercept, x equals to 0, so here y will be equals to 0 also, because 3 times 0 is also 0. Alright, but there's an issue for the third inequality. Because if you see, the x-intercept and the y-intercept is actually the same. If x is 0, y is 0. If x is 0, y is 0. These two are actually the same point. So means we only have one point here. So what we need to do for this kind of situation is we just find a random number of x from this x-axis. Okay, so let's say I choose 100. Right? Let's say I choose 100. So the y value would be 100 multiply 3, which will be y equals to 300, right? So this would be my second point. Okay, this will only happen for cases something like this. Right? If you see the x-intercept and the y-intercept is 0, then you just choose a random value of x here, substitute inside to find the next point. Okay, so now since we have the x-intercept and the y-intercept, or we find an extra point, each of the inequalities here have 2 points already, so we can draw out the line. But also another thing to take note, yeah. Okay, so we found the x and the y-intercept already. We can remove this. Okay, the next thing is when we are drawing the lines, we need to make sure the signs of the inequality. Okay, if you recall back, for inequalities that have equal to at the bottom, right? Equal to at the bottom, it is a solid line. But if you see inequalities which has more than or less than, which means there is no equal line at the bottom, we need to draw a different kind of line, which is the dotted line. Which means for the second inequality here, for the line, we are going to draw a dotted line. Okay, so if you make this mistake, technically you will be deducted 1 mark lah. Alright, so please take note of the inequalities when you are drawing the graph. Okay, so this is the main difference or the main thing that we need to focus on lah, which is the type of the lines. We need to draw a different kind of style. Right, so again, for those that have equal sign, is a solid line. For those which don't have the equal sign, we need to draw a dotted line. Okay? Alright, so now let's go to our graph and to draw out the lines. So things to take note for the second inequality is we are going to draw a dotted line, right? Because again, it is only greater than, there's no equal sign. And for the third inequality, for the 2 points, it will be 0, 0, and also 100 and 300, okay? Which is the second point that we have found just now. And make sure you label the lines, right? According to the equation. But if you see the labels here, I didn't write the inequalities. I changed it to equal sign because we are drawing the lines. Okay, so since we are drawing the lines, we need to write out the equation of the line, right? Which we have learned that equations, we use equal sign. Okay, that's why all of them change to equal sign. Alright, so now let's go to the third part, which is above or below. So what does that mean? So for each of the inequalities here, we already drawn the lines, right? But we want to see, based on the line that we have drawn, which part of the region does it satisfy this criteria? Is it the region which is above the line that satisfies the criteria, or the region below the line that satisfies the criteria. So for each of the lines here, we need to see which part of the region satisfies the criteria, which is it above or below the line? Okay, so how do we determine this? Well, we need to look at the position of y in the inequality. So if let's say y is on the greater side, which means let's say y is greater than or equal to blah blah blah, or y is greater than blah blah blah. Below will be the opposite, which is lesser than. So for example, y is on the lesser than or equal to side, so y less than or equal to blah blah blah, or y less than blah blah blah. So we need to look at the position of y to decide whether it is above or below. So let's look at some of the inequalities here. So for the first inequality, you can see that y is on the lesser side of the inequality, right? Because 1, 2, 0, 0 is greater than y. Y is lesser. So for the line for the first inequality, we are going to look at the region which is below the line, right? Below the line. For the second inequality, you can see that y is greater than 200. Y is on the greater side, which is why for the second line, we are going to look at the region which is above the line. Alright, and for the last inequality, you can see that y is lesser than or equal to. So y is on the lesser than side. So we are going to look at the region which is below the line. Okay, so this is the third part. So now, the fourth part is to find out the region. The region that satisfies all these three conditions, above and below conditions. Okay, so for this one, let's draw a star for all of the possible regions. Okay, so possible regions can be here, 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 and here. So let us eliminate the regions according to the condition of the lines one by one. Okay, so let's start off with the first line. So first line, we need to look at the regions which is below this line. Okay, which means these two regions can be removed. Alright, then the second line, which is this one, we are going to look at the part which is, the region which is above this line. So means that this one and this one will remove. And then for the third inequality here, we are looking at the region which is below the line. So this region is removed. So our region here would be this part. Okay, so now we have identified our region already. So let's shade this region and we label it with R. Alright, so this will be our region R, and make sure the lines that you have drawn touches the end of the lines, okay? Touches the end of the lines, but don't exceed just something like this. Okay, do not exceed it. Make sure it is on the end of the lines. Okay, and we have drawn our region R. Okay, so now with the region R, let's use this graph to answer part C. Right, so for part C1, here it says that we need to find out the maximum number of mid sets. Right, mid sets is y if the number of sets of chicken, which is x, is 200 set. Right, so meaning if x is 200, what will be y? According to the region here. Okay, so let's go to our graph here and then let's see. Okay, so when x is 200, okay, 200, let me make sure the ruler is straight. Okay, 200. So maximum meaning we need to look at in this region what is the highest value of y when x is 200. Right, the highest value of y is, okay, let me change the pen, here, right, this part. And if we see horizontally to the y-axis, which is 150. Alright, so for C1, our answer would be, okay, let me move the ruler a bit. Alright, so let me write out the working here. So for part C1, if x is equals to 200, then y would be 150. For the second part, here it says the profit of the chicken set is 2 ringgit and the meat set here is 3 ringgit. So now it says that the total profit from this sale is K. So we need to express K in terms of x and y. Okay, so let's do this first. Okay, this is the first thing that we need to do in this question. Alright, so this is something similar in part A when we find the first inequality. So let's use the unknowns here, 2, 3, x and y to form the total profit, okay? Or to find the total profit. So let's say for the chicken set, it's 2 ringgit. Sorry, each chicken set is 2 ringgit. So if we have x sets of chicken set, it will be 2 times x, right? And then for the meat set, same thing as well. Each meat set is 3 ringgit. And if we have y sets, it then will be 3 times y. So the total profit here would be 2x plus 3y. Okay, and since here it says the total profit is k, so I'm going to substitute total profit with k. Alright, and this would be the expression. So this equation actually has another name. Okay, but let's go through the second part of the question first. So here it says, hence, draw the graph of the objective function. Okay, so this is a very important thing. The objective function, and we need to identify the maximum profit. Okay, so these are the other two things that we need to find out. So what is an objective function? So objective function is an equation which satisfies the question's objective, which is to find out the maximum profit. So meaning we need to have an equation to find out the maximum profit, which we have already done in the first part of the question. So this is actually called the objective function. Right? Because this is the equation where we find the total profit, right? If we have the value of x and the y, then we can find total profit already. So now we need to draw this objective function in this graph. Right? Because here it says draw the graph of objective function. So how do we do that? So first thing first, we need to have a value of k first. Alright? So for this k, how do we find the value? This one is quite flexible because this k can be any value. Alright, any value. So what I will do is always to multiply the x and the y value and then to find k. So meaning 2 times 3, which is 6. Alright. And then now, if we want to draw this line onto the graph here, of course we can use the same way as in part B just now, which is to find out the x and the y intercept. Right? The fastest way to do. Okay, so let us find out the x and the y intercept. Right, so when y equals to 0, this will disappear and 2 move to the other side, 6 divided by 2, which is 3. And for the y-intercept, when x equals to 0, here will disappear and 3 move to the other side, 6 divided by 3, which is 2. Alright, so let's find the 3 and 2 in this graph. Okay, so if you see there's an issue here because the values here are quite big. And the values that we are trying to find out is 3 and 2. So basically it is somewhere here, which if you want to draw the line, it's very small. Okay, so how can we solve this issue? right? Because this k value can be changed to any value. So for this case, why not we just add a 0 here? So here becomes 60. So meaning for these two values, we will also add 0. So it will be 30 and 20. Okay, so with 30 and 20, it's much easier to draw the line, right? Because for 30, if x is 30, it would be here. And if y is 20, then it would be here, right? This is 20, this is 30. So I zoomed in the graph a bit and you can see this is the graph of the objective function. So x-intercept is 30, y-intercept is 20. Plot these 2 points and then join them by drawing this dotted line. Alright, so for objective function, we are going to draw a dotted line. Okay, so how do I know this is 30, this is 20? Well, you can look at here. So big box here, total units is 50, right? And here we have 10 small boxes. So for each of the box here, it is 5 units. So if you want to go from 50 to 30, we just minus 5 times of 4. 5 times of 4 is 20, so 50 minus 20, 30. So now we have the graph of the objective function already, which is this line. How do we find out the maximum profit? So we know that profit depends on x and y. So if either x or y value has a very big value, then technically we can find the maximum profit already. So what we are going to do here is we are going to place our ruler onto the line or the graph of the objective function, and I'm going to push it upwards until I find the last point in this region R. So why I need to find the last point is because last point usually has a higher x or y value. So if we have that high value, then we can find the maximum profit. Okay, so let me push this ruler upwards and you can see that the last point is here. Okay, so let's zoom in a bit. Okay, the last point is here. Okay, so let us find the x and the y value from this point. Right, so for x value is a bit hard to see. Let me scroll out a bit. Okay, so if I use this ruler, let us see what is the x value. Okay, it's in this line, which is here. So means for each small box, it's 5. So I need to minus 5 by 4 times. So 4 times 5, 20. So 100 minus 20 is 80. Okay, so for our x value is 80. And how about for the y value? Okay, so y value here is this part. Okay, and let's zoom in a bit. So each small box is 5, so I need to minus 5 2 times. So this is 240. Alright, so we have found out our maximum point already. So it is where x equals to 80 and y equals to 240. Right, so now to find out the maximum profit, why not we substitute these two values into our total profit here, and then to find out the maximum profit. Okay, so the working will be something like this. Alright, so our maximum point is 80 and 240. So I'm going to substitute the points into the equation here. So it will be 2 times 80 plus 3 times 240. So if you put this into a calculator, you can find out the maximum profit is 880. And with that, we have completed the discussion of this paper. So if you have any questions regarding this paper's discussion, you can put your questions in the comment section below. I try my best to answer them as soon as possible. Alright, and for the next paper, I'm not really quite sure which one to discuss. So if you have any recommendations, you can put at the comment section below as well. Alright, and I also know that SPM is approaching quite fast. It's just around 1 month. Right, so I think the pressure is quite high, so I just want to make to let you all know that please take care of your health first, right? Even though, let's say, you need to study 24/7, but please make sure to take care of your health, because without health, how are you going to get good grades, right? Okay, so priority, health is always number one. And I'm not meaning physically, I'm meaning mentally as well. Alright? So again, if you have any recommendations on which paper should I do, or which question should I do, you can write it in the comment section below. Alright, so thank you so much for watching this video. Take care, and I'll see you all in the next one. Bye bye.